And we're live.
Hello and welcome to Brothers Code, a excellent whatever the heck this is with whoever we are.
Nailed it.
First try.
Oh my God, that was awesome. That's Eric. I'm Carl. We're writing some more code this morning, and clearly we are in exactly the state of mind we need to be for whatever it is we are about to do. Uh, Picking up off of last time, we're going to be working more with your heat shader, right, Eric?
Indeed.
All right. And okay, so I was very excited because I asked you if we were going to be stuck right before this, like we were at the end of last time. But
hmm
you said that you resolved whatever it was that was making heat freak out. So please tell me what it was.
Well, so a little bit of context. This is what we left off with last time.
Hmm.
So we got some steam going on. It's fantastic. It looks great. The problem is when you try to add heat to it, it is the dreaded blue.
Okay. All right. When you were doing this right before, you freaked me out a little bit. I was like, this looks a lot like it did before, but okay.
Like, if you're sure, did you really fix it? Um,
All right.
yeah, so I have my list of reasons
Hmm.
at the side, so we can kind of start at the top. So the first point was in the main script code.
Hmm.
When we're running the heat shader here, this heat shader is going from this one to this one
Right.
with a little flip-flop using this material flip-flop. The
Oh, that's the
problem
wrong one.
the problem being this one is pointing to the wrong ID.
Ah, that should be one minus, shouldn't it?
Yeah. And that's the first thing.
All right.
So the second thing was that when we're actually adding stuff to the grid,
Hmm. You mean like when you're clicking with the mouse?
when you're clicking with the mouse, yes, um, this doesn't do a sample and then set. It just sets blindly
Okay.
using the green, blue, and alpha elements, which we were then using for other notifiers.
So it was just straight up nuking those other
Yeah,
pieces?
and so it would just nuke it.
Ah, okay.
Instead of only modifying the red, it was using the other thing. Yeah, so messy there.
All right.
And then in the actual heat flow shader, here, or sorry, not the flow shader, the heat shader. Um, this flow, not only
Hmm.
was it being taken from the wrong element,
Oh God, this
or
again.
wrong, whatever index,
Yeah.
but when it was calculated in the flow here, uh, this this value is saved on the new index
Hmm.
and is not a percent. So
What? What is it?
this is the amount that's flowing, and
Oh.
we can't use the amount to back calculate the percent unless we're super tricky here,
Yeah.
and we weren't being super tricky.
Okay. So,
Uh,
hmm.
so I nuked it all
Okay. Okay. And you're just like, forget this.
and kind of went back to the beginning.
Yeah.
Um, and in the flow shader, I updated it to have a get flow function.
Oh, nice.
Um,
Okay.
yeah, the get flow function isn't the prettiest, let's
Hmm.
say, but oh, if I can find it, it's actually not that big of a file, but uh, super unoptimized, making lots of floats that we don't need, but
Hmm.
that's okay
Yep.
because it's clear. It is
Nice.
very explicit about what exactly it's doing.
Yeah.
Um, so after revising the get flow by itself, I implemented the get heat function by actually passing the heat texture into the flow shader so it can pre-calculate the heat flow. This is using heat flow as heat, not heat flow as temperature.
Right. Okay. So hold on. So let me say this back to you. So it's your flow shader is now also calculating the heat transfer. Is that correct?
for the percentage of that element that flowed. That is true.
Cool. Okay.
Yeah. So each element will do a flow and
Hmm.
calculate how much heat that element would also take with it.
Oh, so you're using the GB for heat flow?
Yes. So green
Okay.
is the inward from the north and blue
Hmm.
is the inward from the east.
I like being specific about the direction now.
Right? It's just be very
Yeah.
explicit and optimize later.
Yep.
Like,
Yeah. Oh my gosh. Okay.
yeah,
So we don't have to deal with like, oh no, this should be positive. Wait, no, it should be negative. Oh wait,
no,
hold on. Is
none
this
of that
out and
business.
to the left or?
Yeah.
Got it. Okay,
And
cool.
so in the heat shader itself, I also split this into actually two shaders if Unity wants to update. Yes, I know you're compiling scripts. You should also update the scene. Hooray, updated scene.
Cool.
Um, so what we were doing in the previous one also combined the two steps of flowing the heat
Hmm.
and moving the heat with the elements.
Wait,
The
we
issue,
were doing that or you? Oh no, right. Yeah, yeah, we were designing it that way.
we were
But
designing it that way.
yeah. Okay.
I realize that's a bit of an issue
Okay. Why
uh,
is that?
because first you have to flow with the elements, and then you need to
Hmm.
take that result and the new result of the temperature, which depends on the updated flows,
Right.
and take that to calculate temperature and then flow the temperature.
So it has to be a separate shader.
Yeah, or at least I designed it this way because it made
Yeah.
more sense to me. If it doesn't, I'm sure someone will either tell me or I'll figure it out eventually during the
Yeah.
optimization process. But
Right. No,
in
yeah,
any
that makes
case,
sense. Yeah. Cool.
this is Heat Shader 1.
Yeah.
And in Heat Shader 1, you only care about the flowable textures. So
Hmm.
currently that's water, steam, lava.
Yep.
You grab the pixels and then you basically just sum them up and you're done. So this little calculation, the 2 times water minus 5, is the opposite of the flow shaders 0 0.5 plus half of the get heat in order to get negatives and positives in a 0 to 1 value.
Cool.
And you do that for all of the elements, you send them up, and you're done. And I just maxed this with 0 to make sure that we wouldn't have negatives because sometimes they happen. I don't know why.
Negative heat.
Negative heat.
Hmm.
It's a negative, very, very, very small amount of heat, but that doesn't matter because if it's negative, it's then infinity and everything freaks out.
Right. Yeah. Cool.
So that's heat shader 1.
Yeah.
Um, and we can actually take a look at that by itself if I comment out heat shader 2. Doop, doop,
So this will just do the heat flow,
the heat
or
movement,
sorry, heat
let's
movement.
say.
Right.
So if I have some lava
Hmm.
and I put some heat in it, it flows with the lava.
That's
Hooray!
gorgeous.
Right? It's
Yeah,
beautiful.
that's awesome.
Yeah.
Look at that.
What,
Wait, is
what
heat
it
flowing down into the dirt there?
shouldn't be. Ah, it is.
Okay.
Damn it. I don't know why. I
You know
didn't
what?
save the main script. There we go.
Moving
I
on.
saved the main script.
Oh, okay. Oh, so it actually did the. Got it.
Yeah. So, oh God. Uh, heat. Oh, so much heat everywhere. No,
Everything is
forget
hot.
about that. We're not going to do it step by step. We're
You know
just
what?
going
That's fine.
to put it in there.
Or do the good stuff.
Yeah. So, heat, moving right along, heat shader 2.
Glossing over this.
Glossing over the fact that that didn't work at all.
Nope.
Oh, actually, you know why it didn't work is because I show temperature, and temperature isn't resolved until you run heat shader 2.
Oh, okay. That makes sense.
Yeah. So
Got it.
in heat shader 2,
Hmm.
we take all of the elements, including copper, which I added in,
Hey.
um, some good old wiki conductivities.
Hmm.
Um, what's actually interesting to note here is these are true in terms of per watt kilogram something something something. The conductivity of
Yeah.
like molten lava, water, steam, and dirt.
Hmm.
Copper here, this is not true.
Really?
No. So copper is listed here as 4, It's
Hmm.
actually about 400.
What?
So like
It's
copper
that much higher?
transmits, yeah, copper transmits heat about 800 times faster
Huh.
than water does.
Cool.
Uh, yeah. So that's not counting like convection or anything, just
Hmm.
pure. So anyway, I had to scale it down to four though, because if I didn't, then like these would never go anywhere,
Yeah, the time
like
scale on
real
those.
life.
Yeah, yeah, exactly.
Yeah.
Huh.
But it's a game, so hooray.
Yeah.
We then also have nice capacities, again from Wiki, hooray.
Yep.
So everything here is
Good old
relatively true.
4.18.
Yeah.
Yep.
Um, and then we do some temperature calculations, the temperature flows, back calculate that back into heat flows, add up the heats, and then also store the capacity in green. I don't use it. The conductivity in blue, I also don't use it, but maybe I want to put a highlight on that later. And alpha
Hmm.
is the temperature.
Yeah, it might be a neat readout for later or something. Like one
Yeah,
of
so
those.
if somebody wants to be like, oh, what are the heat
Yeah.
capacities here? What are the conductivities? Where is it flowing? Um,
Man, that's
but
cool.
yeah, you also might have seen earlier I built in a highlight function.
Hmm. Highlight.
uh, a highlight function. So it used to be you had to go into the world shader to change this, but now if I
Hmm.
have lava and I want to highlight lava, I just press a space bar and that is lava.
Oh,
And
cool.
I
So it'll show
hit
you
into
whatever.
there.
It shows you only the element that you're highlighting.
Oh, yeah, so the elements
Ah,
again are in the
cool.
top left, and
Yeah,
whatever you have selected, you can highlight.
that's really
Um,
cool. I was
and
wondering what you were doing. Yeah.
if you hold down the selection and select something else, it won't
Hmm.
update. So you can still look at your, for example, here is water while I'm
Hmm.
doing steam.
Hmm.
Very useful for heat. So to show off what happens in the end, I built this nice little playground on the side, and we'll just
Yeah.
fill this all with lava because lava has a good heat conductivity. So that's where the lava is.
All right.
And we can fill the middle one with heat. So here's the heat. It's flowing out. It's lovely. It's getting hot, getting super hot.
Lava doesn't start hot.
No, nothing starts hot. Nothing is initially hot.
Got it.
So we added a lot of heat
Oh,
to this
hey,
lava,
look at that.
and it's starting to flow out a little bit through this giant dirt wall.
Yeah.
And through the thin dirt wall, it's sort of heating up the lava on this side,
Yeah.
which is fantastic. But we can take some copper and be like, oh, there's some copper pipe down here through this dirt,
Yeah.
and if we stick it up into that lava, you can see the heat flowing into the copper pipe relatively quickly.
That's awesome. Man, this is cool.
Yeah. And then if I want to heat up this water on the left-hand side, I can stick a copper pipe over to the lava on the left-hand side, and the more of them that I stick there, the
Yeah.
faster it's gonna heat up.
That's really cool.
Yeah, heat transfer.
Heat transfer.
Also, so that's the conductivity aspect.
Yeah.
For the capacity aspect, if you have a nice little ramp here,
Hmm.
um, and I have a blob of dirt, and I heat up this dirt a lot,
Hot dirt.
hot
Coming through.
dirt, and I flow some water over it, the water's not really heating up. Like maybe a little bit. It's starting to get a little bit
Yeah, I can
less
see a
hot
little
around the
yellow in there.
edges.
Yeah.
But if I take a nice little ramp of dirt and I stick some copper on there and I heat that copper up,
Whoa.
whoa, yeah, and I stick some water over it, the water's like, give me that heat, and copper's like, okay,
Oh, cool. Yeah, I just completely drained it.
yeah, because it is a very low capacity
Yeah.
but a very high conductivity.
Dang.
So that's where it is.
This is
Let's
cool,
give
man.
the
All right. So what's the plan for today? This looks awesome.
Yeah, thank you. The plan for today, um, well, I didn't do flow based on capacities. So when something flows half of, for example, the lava out of it
Hmm.
and takes that, it just assumes that the whole thing has the same capacity and just takes the direct proportion of heat out of the original cell.
Hmm.
and that really should be a proportion of the capacity. So if you
Oh,
take
rather
one,
than, yeah,
yeah, if you take 1/10 steam, it doesn't take 1/10 of the total heat because steam doesn't have very much capacity in it. Or maybe it does, I can't even remember.
it
I have
has
to
like
look at
half of water, I
capacities.
think, right? Yeah.
Yeah, well, steam, yeah, okay, so steam would have more than lava, for example.
Hmm.
In any case, but that isn't really super exciting, and it works right now anyway. So I think the most exciting thing to do would be state transitions.
That would be cool. You want to boil some water?
I kind of want to boil some water.
Let's do it.
All right.
So, do you have an idea of how to get started on this, or are we just winging it?
I don't really have an idea how to get started on it. I was
Okay.
thinking like do it in the steam and the water flow shaders that they would like just update themselves based on temperature at the same time.
That seems
But
right. Are you
I'm
flowing
not
both?
quite sure.
Are you flowing both at the same time, or do they flow independently?
Uh, yes and no. So they all flow inside of the flow step,
Hmm.
which is this flow, run the shaders for flowable elements, and it just runs through all the flowable elements one by one and updates them all.
Gotcha. You know, I was just thinking out loud here. We may just want to do like another shader entirely that just takes the water and steam and then does their state transitions.
Well, so we would have to have one shader for the steam and one shader for the water
How come?
because you can
Oh,
only modify your
because you
own
can only
pixel.
write one. That's
Yeah.
true. Yeah, we would. I don't know how hard it's going to be to integrate with that with the flow. It's the only thing.
Yeah, yeah, yeah. No, it would be super tough
So,
because I'd have to say like, what am I transitioning from? What am I transitioning to? Like, what is my listening element?
mhm. Oh, right, yeah. Because
Which,
especially well with water, you can transition not just well, I mean, you can only transition one direction right now, right? Like you're not gonna have frozen water.
mm,
You're like,
I
maybe.
will, I will have
Well,
frozen water.
okay. So in that case, you're just gonna need. I mean, logically, you'd need an output shader for every type, right?
Mm, yes.
Every type that can transition, you have to have an output shader for that. So that's gonna have to run a shader anyway. So then you
Hmm.
just give it the input shaders that it needs, and then away you go, I guess.
So in the flow shader itself, I could here designate like uh, hot transition and a hot temperature and a cold transition and cold temperature, so that it would check that
Hmm.
pixel's amount,
Hmm.
current amount, assuming no flow, and
So
transition it.
instead
Uh,
of you're saying instead of flowing, it would.
well, that's the problem. Is like it does need to flow. The flow step is going to happen anyway.
Hmm.
But so yeah, maybe it can't be in the same shader, but I think it can be generalized.
Okay.
So so we would only need one shader type that can have multiple instantiations.
Hmm. I don't know. Do you want to support transition to plasma?
No, plasma's not a thing.
Fine, I guess.
Doesn't exist. When I was in school, it was three states of matter.
Yeah, now we're up to what, like six or something?
Yeah, well,
Yeah, because you can
I'm
get
I'm happy with three.
yeah, Bose-Einstein condensate. I think that's one of them.
That sounds about right. I don't know.
It's all elements do wacky things as you get them close to absolute zero.
Mm,
That's all I remember. Anyway, back in the game world.
indeed.
Yeah.
In here, currently we have lava and or heatless lava and water mixing, and they don't do anything.
All right. Let's do both then. So, how how much work is it to just create lava that's hot?
Not too much, I don't think.
Because do you want to
Uh,
start there?
yeah, we can just assign a initial temperature.
Cool.
Hmm. Hmm. So this is the placement.
Hmm.
This render texture stores the element that you're going to be adding to. And this is where the element is actually placed. And it sets so does a get pixel set pixel for that active render texture. I guess we don't need to touch any of that. It's just at the end here when you switch back, when you after you do the blit,
Mhm.
you'll then need to update the heat texture in the exact same way that you would update a heat. So take the render texture and blit that texture. Heat text, because we haven't used that very before.
Nope. That's very unique. Easy to search
Mm-hmm.
for.
Yeah. Render texture active.
I see what you're doing.
Yeah. Heat texture, and then we get it. Then we read the pixels. That's fine. And then here we need to set the pixels. Bar temp 2. At pause grid.
Right, you're gonna have to do the same iteration, right?
Dang.
I mean, you could just mix these things together.
Can I?
Yeah, you could put so render texture.active is only necessary for the read pixels, like for the read pixels command to actually be executed. So you could
Okay.
change that over
Mid.
up at the first place that you call it. So right after you
Huh.
create this new texture 2D, then you can create the heat texture here. Yeah,
Okay.
and read the heat textures pixels.
Alrighty, so now we have the additional heat text
Hmm.
that is active. So we're not going to need any of this.
Yeah,
No, none of that. We'll need a switch.
to get the additional heat or like the default heat.
Yes. You know what? No, we don't, because we already have a switch. So we just put it in there. Float additional heat to add equals 0. Oh, sorry. F.
Is it really complaining about it just being 0?
I
Oh,
don't
it's
know.
no, it's saying it's not used.
Okay, whatever. Dirt. Dirt is crap.
I mean, sometimes, but
Because, yeah, well, because I want it to be a certain temperature, and that means I have to divide by the capacity, which means I have to pass in the capacity parameters as parameters to the other one, or just copy paste everything.
oh, because it's all stored as capacity, not as
It's stored as heat.
or it's stored as heat, not as temperature.
And if I want it to be a certain temperature,
Got it.
um,
Good old constants to the
active
rescue.
fix. Oh no,
They just have to have F's
double
after
the
them.
float.
Yeah.
Well, it doubles now.
We double now.
Yeah, boy.
All right.
Because that's easier to do. So the additional heat to add
Mm-hmm.
is, so for dirt, I have a certain capacity, and the temperature that I want it to be is in Kelvin. Is it Kelvin? No. What does my temperature even output as? 0 to 1?
Yeah, it's 0 to 1, but I mean,
So my temperature is 0.5. Uh,
it's scaled Kelvin.
yes. Temperature is heat divided by amount. Oh, Actually, it depends on the amount that I'm adding, I guess.
Oh, that's even more complicated.
Well, I'm always adding 0.3.
Well, can
But that's
you,
a min.
so can you just select the temperature up there and then calculate the heat when you're actually placing?
Yes, I can.
You still need the capacity hack,
Total
but
target temperature 0. Target temperature in Kelvin, I guess. Well, no, in units. It's just units. Target temperature is half.
1/2 temperature, please.
Yes. All right, let's make it a nice cool 0.2.
0.2 temperatures. Got it.
Because you know what? All of that. If you add steam, it's is it going to be cold steam? We're going to make it cold steam.
Yeah, how does that work?
I don't know. We can
It
make
just
it. Yeah,
immediately transition to water.
there's going to be a medium steam. The water's going to be nice cold water.
Cool.
The lava is going to be fairly hot, or like really hot. And heat doesn't require a target temperature because it's heat,
Get wrecked.
so it'll maintain 0. We can add it for explicitness.
You can do a check later then to see if your target temperature is 0, then
Yeah.
you can just not do the second piece.
So this is additional heat text dot set pixel. That's what we're going to do here. Something like that, and something like this. And there's like a temp2 going on here.
Temp for temporary, not temp for temperature, right?
Yeah.
Nailed it.
Old pixel.
Look at you naming things.
Right. Var temp. It's the best.
Temp, hacky
Old
hack,
heat
temp,
pixel.
fix please, to do.
The best is heat text. Wait, no, additional heat text. So the old heat pixel is the additional heat text getting that pixel, and the additional heat text set to, well, whatever this one was.
I guess you got to pull that into a temporary.
Yeah, something called var temp, maybe.
Maybe, yeah. I don't know. It's pretty. I hear that's a pretty good name.
Yeah. Added amount is that minus the old pixels amount. Right? Yeah.
In of.
Because I only wanted to add 0.3 up to 0.5.
Oh, you don't want to. Okay, got it. Yep.
Or you're not going to add 0.1 up to 0.5. And there's minus the old pixel. So that's the amount added. And this is the added amount plus the old pixel.
You're going forward. You're doing the calculation, then undoing it, and
Yeah,
then
well,
doing the
because I need the
calculation
added
again.
amount to get this amount out.
Got it.
And because that's how much temperature I need to add. Because it's the amount times, right, temperature is heat over amount. Why am I blanking?
Temperature is heat over amount, so temperature
Yeah.
times amount is heat.
Temperature times amount. Sure.
Right?
Well, times
Temperature
capacity.
equals heat over amount.
Oh, sorry, amount times capacity. Wait, no.
No. Amount is amount of material. Capacity is. You just
If I
furiously
have
scribble on something for a second.
yes.
I heard that.
If I have a certain amount of material
Yeah.
and I have a certain amount of heat,
Yeah.
the first part is heat divided by amount. Where does capacity come in? Because so yeah, capacity is on the denominator.
hmm
So it's heat over amount times capacity equals temperature. Because if you have a lower capacity, you'll have a higher temperature for the same amount of heat.
Right.
That's good. Yep. Okay, so the amount times the capacity of
Aren't you excited to calculate
Aha.
some capacities?
Double my capacity.
Hmm.
Here is dirt. Oh, this is gonna be great. This is good content right here.
Yeah, yeah, man. Look at this. All
Copy
that
pasting,
copy. Yep,
renaming stuff.
that's like 50% of coding.
Yeah.
Copy, paste, rename. Yeah.
Copper. So that's
Cool.
my capacity. Oh, and I didn't even look at me mixing styles. What is this? Unresolvable. That's okay. I'll resolve
Nothing is impossible.
it. So, yeah, that wasn't
It's
resolvable.
so
That's fine.
unresolvable.
Um, my capacity times my amount times the temperature will give me heat.
Cool.
This is heat.
Why? Because I said it is.
uh, and that replaces this plus the old heat pixels bar. And then we want to keep the old GBNA question mark.
What are those used for in the heat texture?
That is the capacity, that is the
Right.
conductivity, and that is the temperature. But they're all overwritten. They're never read.
I
So
mean, you could read them
that's
right
fine.
now.
Well, I mean, I could update them right now, but I don't want to.
Okay, fair.
It'll be one frame behind, and it runs, well, not frame, even it'll be one update behind. It runs 2,000 updates per frame.
Yeah,
So
that's a lot of updates.
target temperature is in there, plus the old pixels cannot convert from double to float. Screw you. C style cast for the win.
Perfect.
Uh, so heat added plus the old heat,
Yep. Gives you
and
new
we're
heat.
setting that to additional heat text. Does that make sense?
Yeah. And then you just got to remember to blit your additional heat text at the end,
And also do it for this one.
I guess.
Uh, let's just do that, and then fix these.
Oh, because this is
Ugh.
the single point version, right?
Yeah, higher temperature single point. Um, doop, 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 doop.
Oh, so this one can go up to a higher maximum.
Yeah, higher maximum, and it goes faster, but it's at a single point.
I see. Okay.
I don't know why. Just decided to do that.
Yeah. Good for
Big
testing.
big soft paintbrush versus pencil point. I think that's right.
Mm-hmm. Looks right to me.
Okay, cool. So additional heat text now has stuff in it. Do I need to remove things?
Remove. If you
I'm not
remove
going to
stuff,
remove things.
you don't need to remove heat.
Do I?
I mean,
I mean, I could just say you can remove heat separately from stuff, and if you remove stuff without removing heat, it gets hotter?
yeah, exactly.
Question mark.
Yep. I think that's the way that should work.
Okay. Well, then why do you place it with heat? If you place it and then remove it,
Reasons?
now you have heat. It just explodes. It just melts.
Exactly.
Watch out for the melting. And remember to remove your heat first before you remove your dirt, otherwise it'll turn into lava.
It's fine.
Yeah, probably. So here we blitz some stuff. I don't want to make an if statement, so I'm going to do that.
Wait, doesn't it do the same thing in every case?
Except for one, which is when you're actually placing heat. Hep, 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 hep. That looks like good code. All right, what does it do?
Let's run it and find out.
Pretty much, I love Unity for that. It's just like, okay. Yep. Did I get heat? I did not get any heat.
Why didn't you get any heat?
I can get heat if I do heat,
Yeah,
but if
but
I do dirt,
placing lava didn't give you any heat.
copper. Oh, that's why I'm blending the wrong texture because it's killing my heat texture 0. For some reason, yeah, okay. So it's killing my it's killing my heat
Hmm. Oh,
whenever I click.
when you click the new one, then it kills your existing heat.
Yes, I don't know why. Well, we're gonna find out. So I'm reading here the additional
Hmm.
heat text. Here, the
This
old
should
heat
only
pixel.
be happening for the stuff that's like right there. So it's not like it's even overwriting every pixel or something.
True. Right, so I shouldn't even be looking there. I should be looking here.
Wait, there's a text.apply. Did you remember to text.apply somewhere else?
I did not remember to text apply.
Okay.
Additional heat text apply.
Yeah.
See
Maybe
what
this
that
works.
does.
Let's see if it works.
All right. So we have some heat down there,
Yep.
and then we make some dirt up here, and the dirt has heat. Hooray! Lava has more heat.
Yay!
Steam has lots of heat,
Steam has lots of heat.
which flows faster than the steam. I don't know. That's interesting.
That's some very flowy heat that steam has.
Yup.
Well, but the heat's
Uh,
but steam is very conductive, right?
is it? Maybe. But in any case, why is it? Why is the? Uh,
Why is what?
hmm, this is. If I
Oh,
go in that direction, it's a large amount. So it's a very small amount of material with a large amount of heat, which means a high temperature. But if I go
oh,
in this
that's
direction, it's not.
huh.
Yep.
Well, that's interesting. Is that just an artifact of the way it's being displayed right now?
Um, maybe. I have no
Like,
idea.
is the color exponential or something like that?
No, no. The thing is, the temperature is heat over amount times
Hmm.
capacity, and if the amount is very very small, and the heat is slightly larger than small, then the temperature
Oh,
is
yeah.
extreme.
Right. So that probably is why it's super high, right?
Yeah, probably.
Yeah. Because it kind of
And I
evens
have,
out at the end there.
yeah, I have in the world shader that if the amount is greater, or wait, no, is it in the world shader? No, it's in the flow shader. Heat 2 shader is what I meant.
Heat 2.
This only is run when the height is greater than small.
Hmm.
And so if I up small here, maybe that'll, otherwise it just says 0. Uh, nope, still
Hmm.
does the thing. You see it's more contained now in
Yeah.
the center.
Yeah, yeah, because it's not flowing with the little amounts.
So it's
Does it need
small
to
as small
be?
again.
Yeah,
Am I adding too much heat?
making it
The old
angry.
heat fix. Maybe.
Hold on. Target temperature, my capacity. My capacity is always from 0 to 1, right?
It should be, yeah.
Oh,
Yes,
because
it
it's
is. It's
scaled.
always 0 to
That's
1.
right. Yeah. Okay. And target temperature is also 0 to 1. Added amounts, also 0 to 1. Yeah, so you should be fine.
Mm, mm,
Ah, yeah. That might be
F
something.
dot max.
Yeah, capital Math F and capital Max, but yeah,
Hup,
got it.
maybe that works. because if old pixel r is large, it will max at 0.5. Wait, what? No, that should be a min. No, 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 sorry, that's max.
That's max.
That's max. This is a min. That's true. Okay,
Yep.
good. This is
Yeah, you're
again
right. It'll
max
max at
with
zero point
0,
0.5.
and then go
Yeah.
negative, and we don't want to add negative. Compiling, compiling. Looking at heat and placing lava. And placing steam. Nope, still
Dang it,
good.
Steam.
Dang it, steam. In any case, lava's hot.
Lava is
Hooray!
hot. That's pretty cool. I mean, hot.
Why is it so much hotter if I go quickly though? If
If
I
you,
do
is that what it
that,
does?
and if I do this,
Oh yeah,
and
you're right.
that,
Yeah, now it's like super hot.
and it doesn't even out.
Ah. Okay, yeah, that's weird.
Hmm. So the answer to how hard is it to just add some heat is apparently difficult.
Yeah. Well, I mean, at least we got the you got heat spawning. So if like, we can debug this piece later and do the state transfers just based on what heat it
Ah,
has, right? Because I mean, it's still
yeah,
kind
then we don't need any of this.
it mostly works. What, state transfers?
No, we don't need any of this to do state transfers because then I could just heat up and cool down stuff at will
Yeah, that's true.
with the heat command.
But it is
It's
cool to
funny.
see lava
It
flow
is.
into water or whatever, right?
It is. It is. It's
Yeah,
true. All right, so
cool.
this does stuff.
Yeah. Let's take a quick break since we've been going for an hour and then
What?
we'll come
Okay,
back. I know, right? And then we'll come back and do the state transfer piece. Sound good?
sounds good.
All right. We will be right back. Hi everyone, we're back. We've been doing a little bit of offline debugging here, but right, where were we?
So we're trying to get the temperatures to show correctly, and I
Oh,
realized in
that's
the
right.
world shader I wasn't or sorry, then the flow shader when I was making the temperature, and by flow I mean heat shader too. When I was making the temperature, I wasn't multiplying or rather dividing by capacity or
Yeah.
the amount on the bottom, which is giving a false temperature readout.
Wait, A is the alpha's temperature, not heat? I thought it was heat.
Alpha's temperature.
Alpha's
Heat's heat's
temperature.
in heat's in red.
That's right. Okay, and you want the temperature readout to be correct.
Yeah. And temperature, as we discussed earlier, is heat divided by amount times capacity.
Yes.
But the problem is when we run this,
Wait,
even mhm,
are you getting the divide like the 0 1 range error again?
I don't know. So I have
So,
it maxed with small,
yeah.
and when I divide that, I make sure it's not negative. So that should work.
Well, but didn't you say that you did like a, back of the napkin calculation? You said your temperature was going to be 30 Kelvin for one of them. Like if you just place copper, because so one of the problems is
Yes.
copper's really hot right now, right?
Yes. So if I have a very small amount of height,
Yeah.
so I have like zero point 0.1 copper, and the capacity of copper is like also zero point 0.1 or point
Hmm.
something. In any case, low. Yeah, zero point 0.3 divided by 4.
Right. So it scales into 0 to 1.
Yeah. So small and small, when you divide heat, which is let's say 1 by small, you get huge.
Right.
So
But
heat pixel A is going to be greater than 1, almost guaranteed.
right. Which that's what we gotta nuke, right? Because if you output something that's greater than 1, it's gonna get clamped to 1.
It doesn't though. That's why height
Really?
works. Yeah.
Wait.
It just doesn't display greater than 1.
Oh, I see.
So if I can find the right scaling, that would work. But what would be really useful right now is a mouse over debug update text.
Oh,
Update
to show you what
text.
you have in each one.
Yes.
Gotcha.
So,
Handy that you have this.
right? So through the text, element selection. So that's just the element selection text. And I have the position on the grid from pause grid. So I can take that and try to get some values.
So you're just gonna sample the texture.
Get some values. Output values text. Sure. Wait, is this? No, this isn't C sharp 11 or whatever, is it? Where I can just put this all in a dollar string?
No, it isn't.
Bummer.
Yeah, no string substitution, sorry.
That's right there. Okay, so happy now? No, of course, I need to say it's a string. It's a string. Right, everybody's happy. Okay, so we're gonna do some stuff with PosGrid in there. It's gonna output it here. We want to sample the heat texture. So we can just do this and that. Output values texture text. I'll keep it. Oh no, additional heat text is in the wrong naming convention.
Quick, fix it, fix it, fix it, fix it, fix it.
Nobody saw that. All right, good.
Nope. Or
Output
that.
values text. No, let me see that part. Output values text we want to read because the active texture is heat texture. And then output, read that. Really read it for real this time.
Hmm.
And then
For
from that,
realsies.
get a certain get pixel from the pos grid, which we already have calculated. And now that we have output values pixel, we want the alpha, which is
Which is
temperature.
a temperature. Yeah.
Dot two string. Yes. Doing it.
All
All
right.
right.
Now instead of poking around in the dark, now we can actually see what it is.
Yeah. It's either going to update or it's going to stop. Oh, there we go. I got a 0. But I think I tried to stop it anyway. Oh. Hello, Unity.
Usually it
It's
should reload
time.
just
All
fine.
right. So we have 0 temperature.
Yep.
I'm going to add heat somewhere. We have
Hey, you got a little bit of temperature. 2.4
temperature. Yeah. Which is gradually decreasing
as it
as it's
spreads.
spreading. Yeah.
Okay.
And over here it's gradually increasing as it's being spread too. So great. Lava. This is 0.4 temperatures. And is
It's
now
like 40
7
something.
temperatures. This is all lava. It is a nice 0.8.
It's that section on the top there.
It's like 600 something.
Is this compressible lava? Is that what's going on here?
Yeah, it has to be a little bit. Well, yeah, when you spray it around, it's there we go.
Gotcha.
That'll compress in the other direction. So here it's a
Hmm.
temperature of 15. And here it's 0.5.
That's weird.
This is interesting.
Because the temperature should even out, right?
Yes. Why is this
2000.
2000?
That's that's pretty warm.
That's yeah. I mean,
Huh.
ooh
I thought introducing this piece would just be like, oh yeah, we just set the temperature and then we're good to go, right?
Yeah, that's what I thought too.
Hmm.
Oh wait, no, this is my capacity. What am I doing? I want to get rid of it here. Let's
Now,
just not let's not do that blit.
oh, you're
Let's
just
see what
not going to add any
happens.
heat?
Yeah. So can I wait? What did I read pixels with call read pixels? Is this for better? Not true. That's unfortunate. Okay, that's steam and it has no heat. There's some heat. There's some heat. What temperature are you? 40.
And 0 over there as it's spreading.
Yeah, it's 0 times 10 to the negative fifth. As yes, it spreads. Temperature of 19.
Yeah, it's just going down because it's distributing its heat, right?
Yeah.
That pattern is really cool.
Ooh, buddy. Yeah, it is. There's also a massive amount of heat. So we're in the 20s.
Yeah, right on the edge there.
Yeah. Uh,
So, okay, just thinking physically for a second, how does
mhm.
something heat up something else to a temperature above what its own temperature is?
How does something heat up something else to a temperature above which its own temperature is? It cannot.
So, well, because that's what it looks like it's doing, right? Because you add heat into the middle of a blob of water, and
Mhm.
then it's recalculating heat every frame, I guess.
Yes.
And like as the heat distributes itself, when it gets to the edges, then it gets really, really hot because there's an amount of heat being transferred into it that is so much greater than the amount of material there that it ends
Hmm.
up increasing its temperature beyond what the temperature was of the thing that the heat is flowing from.
Yeah,
There's probably an easier way to say that. Does that make sense?
this might be a floating point math issue.
So what I'm saying is, can you just clamp the new temperature of the during heat flow? Can you just clamp the
Hmm.
new temperature to always be less than the temperatures of everything around it?
Oof. Uh, Probably.
I don't know
So,
if that fixes it because because I guess there's one of two things, right? There could be the that the heat flow calculation is incorrect, or that you're right, it's like a floating point thing, in which case you need to clamp the original temperature, or you need to do just clamping on the temperature to make sure that that doesn't happen.
mhm.
Does that make sense? Like,
No.
am I thinking about this right?
But you know what?
Hmm.
That means we're doing a temperature calculation incorrectly as well.
What do you mean?
Because I'm not following my own rules.
Uh-oh.
So heat over average capacity,
Yeah.
fine, but it needs to be multiplied by the amount. Because temperature is heat divided by amount times capacity, not just capacity.
Oh, so you think that this might be it?
Yeah, so it's flowing, in a different way than it is being calculated. So the
Got it.
calculation of the temperature gradient needs to also include the height, height,
Height. Height.
just the height,
Height.
something like that. And we get our news, our Nesu
Nesu.
all up in here. So temperature equals heat divided by capacity times amount.
Thanks, comments.
Yes. So does that work? Probably. Does this work? I guess. Because
You're less confident about this one. Yeah. Yeah.
conductivity, this is just a conductivity
Yeah.
dir two. Conductivity
Dur.
times conductivity times difference in temperature. Fine, that works. Heat
Cool.
flow in is the heat flow, gets the heat flow from the capacities. Is this true?
Yeah, because this has no amount in there, right? Right.
Uh,
So,
F12 not working for me. Get heat flow. What does it do? Temperature flow and capacities. How much heat will actually flow? If this much temperature flows from A to B, how do I know how much heat is flowing?
yeah, shouldn't this be the heat flow?
This is getting the heat flow.
Right. But can you pass in? Oh, wait,
Well,
this
I
is
know the
getting the heat
temperature
flow.
flow.
Oh, you know the temperature flow.
Yes.
Wait, wait. Okay, I'm there. All right, got it. Yep.
Yeah.
So,
So if I know the temperature gradient and therefore how much
mhm,
temperature will flow, I need to back calculate the heat so I can modify the heat variable.
right. Which means then that you need the amount in this, right?
Because
Because it,
heat equals temperature times amount times capacity. So float my capacity, float my amount, float my amount, capacity, float their amount, and we multiply this in here and this in here, and we go to where this was used. Height, something like that.
height,
This,
height
yes.
n.
Well, this is
Oh, this
this.
is this. You're
This is
right.
this.
Oh, and then the
There's
capacity.
theirs.
Yeah.
Oh, oh god,
That block copy paste is so good.
that's very nice. Height. This is Nesu. Does it work? Let's find out.
Let's see if we just blew up everything again. We're really good at
Maybe.
that.
I mean, it could happen.
So let's see if
Uh,
does normal heat
okay.
work?
Heat putting into stuff.
Okay,
It
it looks
seems
like
to
it's
work.
still spreading a little. That's
I got copper here. Oh,
okay.
oh yes. Oh yes, spreading so nicely through that copper.
That does look pretty good.
Hmm.
Ooh, look at that
All right.
spread.
Lava. Whoa.
Whoa, what just happened there?
Trippy.
S-
Trippy.
So,
I mean, it looks cool. So that's
yeah,
where the lava is.
yeah.
That's where the heat is. Oh,
This
sorry. That's where the heat is.
this is where the heat is.
Well, that's temperature.
Okay.
Resolved temperature.
Man, that little like blorp off the end there was pretty cool.
Right. So maybe we'll just keep it just in case it's cool. So in the heat, if I have heat in an object, it looks
Yeah.
to spread properly.
Yep, that looks right.
Um, like, is it
Well,
fixed now?
can
Can
you
we
can
just
you
like
drop?
uncomment stuff?
Can you? Oh, right, yeah. It's
Let's
all just
find
gonna
out.
work, right?
Yellow, we did it.
Do it.
uh, I love it when things work and I don't know why. So copper is a certain temperature. Dirt is not the same temperature.
Nope.
Lava is also not.
That's lava.
That's lava, man. I don't know what's going on here.
Why is lava
So
not hot?
additional heat still doing its thing. Heat 2 shader
Wait, did
should
you? We should inspect the like. I wasn't looking at the number. I don't know. Were you looking at the number for heat or for temperature?
for temperature.
Yeah, that's in the top left
For
that you
temperature.
added in your debug thing.
Lava. So it's yeah, it is presenting as zero point 0.8. So
Yeah.
this is correct. The visualization. Ooh, yeah, it's all zero point 0.8. It's all uniformly zero point 0.8.
Hey.
Lovely.
Okay, that's good.
Copper. Copper is zero point 0.2. Oh God, is it working? Oh no, it's working. Why is it working?
Whoa, what happened there?
That was a bug. That was if you go this direction
Oh, then it,
instead of just clicking. If you click and
huh?
drag,
Then it like
then
adds more heat.
you can get a
You
temperature of 100.
you can get some very very
It's like
warm.
very hot lava.
Yeah,
Steam 38.4. That's
point
correct.
four.
And water should be zero point 0.1-ish. Yeah, so that's correct. So as long as you don't move your mouse,
Yeah. Hey, but that's a different error though, right?
that is a
Like,
different error. So I count this as victory.
yeah, I count this as victory too. That looks like a commit.
Yeah, it does. Hooray!
Yay! That's
Uh,
exciting.
uh, Push
Even though it's
changes
still a
immediately.
little bit broken, but
A little bit.
that's all right.
Added heat. Uh, oh. Added. What is the commit message? What did we add? What did we do? What did we add?
Hmm.
What's
Uh,
the commit message here?
added the added, I mean, temperature to elements, default temperature to elements.
Yeah, default temperature placement. Default temperature on element placement. And
And it,
fixed all of the temperatures.
yeah,
Fixed temperature calculation.
yeah, it works 50% of the time, every time,
Mm-hmm.
just as long as you don't drag in one direction or the other.
Yes. Just keep your mouse still, boy.
Yep,
What you doing?
just,
Oh,
just keep it
stop
still.
it.
You don't get the drive. No.
Why does it do that though? Something we can figure out later.
Yeah,
Uh,
you want to do
so
transitions? Because those
I
are
kind
those are
of want to.
exciting.
I kind of want to get the lava to be looking hot.
Yeah. Okay.
So I think it's just a number change because it'll cap out anyway. I mean, the
Oh,
lava's
right.
kind of
Don't you be dragging that mouse?
lava. Is it hot?
Lava.
I mean, steam. Okay, I'm not even dragging the mouse, and the steam is still ridiculous.
How ridiculous is it? Like mouse over it.
15.
Oh, it's 15. Why is it 15?
I don't know, but if you place inside of an already placed unit, it's fine. It's
Well,
only
that,
if there was 0 before.
huh. Wait, is that because, oh, hold on. No, the added amount. Okay, so what I was thinking is it was using the amount of material that was there before you were actually placing this,
Hmm.
and that it was the added heat was being computed using like a zero amount, but that's not true because you're computing it using the added amount. Um, so you're always adding, well, no, you might be adding, okay, so you might be adding a very small amount, right?
Yes.
Oh, but it's not divided, so that doesn't matter. Math.
Temperature times amount times. Oh, this is why.
Target temperature, not minus current temperature.
Yes. It needs to be the added temperature. Temperature difference.
Okay, okay, hold on. I think that we need to change this calculation.
Yeah, that
Uh,
sounds good to me.
I mean, change the form of it to not be an additional heat added, but just
Uh-huh.
you recalculate the total amount of heat in that pixel based on the new amount of
Uh,
stuff that's there.
okay.
So like you just straight up say, hey, whatever is here right now,
It's now this temperature.
it's now this temperature. Yeah.
Okay. I mean, that's reasonable, I guess.
I mean, it's kind of a pain in the butt though, because you got to know all the different everything that's there. Wait, but don't you have you have something that has that, right?
That's average capacity.
That's average capacity. So average capacity, but you also need average amount or
Hmm.
total amount,
You just
total amount
you need a total amount times average capacity.
of all the stuff there,
Yeah.
which you have.
And because wait, no, do we have average capacity?
I think you
We
did.
don't have average capacity here.
Isn't that part of the heat texture though?
You know what? I can make this super easy
Yeah.
and just not add, just set.
Oh, not add to the current, but just set to a value.
Yeah.
Yeah, that does make that easier.
Hmm.
As long as there's no other material in that same location.
Which we can't control because there are other materials. Dang it! So we'd have to clear all the materials.
Right, you have to clear all the materials there. Uh, okay, so hold on. Do you have the total amount of all elements at that location? Is that a thing?
I mean, I can calculate it.
I thought you
It's
had
height.
something that it's height, right?
Yeah.
So
Are we
don't
at
you
the point? I mean, I have last round's height, so yeah, I could read it.
so if you read last round's height,
Hmm.
then you also have access to last round's this element's height, right?
And also, actually, the because I'm storing the capacities, I already have access to the average capacity and average conductivity of this cell.
So would you be able to essentially calculate the averages without this one and then change this one's value and recalculate the averages with it and then use that to set the temperature or use that to set the heat?
Possibly.
Does that work? Is that a thing? Because you could take you could take the average, you know what it's being averaged by because you know how many elements there are, right?
Hmm. Yeah,
Or is it weighted average?
it's a weighted average.
Dang. Well, no, but you have the total amount of everything, which is
Yeah.
the okay. So you can then get back to the sum. You see what I'm doing is so to reverse the calculation.
But what is the end of the reverse calculation?
So when you can get the sum of all heats or sum of all the values that you need, the capacities and the uh, conductivities without the current element. That way, when you change the amount of the current element, you can redo that calculation to get the new averages in order to recompute the heat at that location given a certain temperature.
Hmm. Hmm.
Basically, saving you from recalculating everything from every single texture. I mean, we could just recalculate everything from all the textures,
Yeah,
but that seems like kind of a pain.
it is kind of a pain. I wish there were just a divided by symbol somewhere that I wasn't doing correctly. Great.
That'd be a lot easier, wouldn't it?
Yeah, it would be.
So, but that is it though, right? Like that the heat just needs to be set and not added.
Yeah, but why does it work if there's something already there? and not even the same pixel, or not even the same element. So what is supposed to be putting
Does
that element in void and putting that element in not void?
so this the my capacity, maybe
Yeah.
does that need to be like the capacity of the average capacity instead?
Average capacity would be my capacity if you put it in void.
Oh shoot, you're right. Is it an update order thing?
I mean, I can try. So in the place one, the
Hmm.
added amount is going to be that much.
You're just gonna say point 0.1 always, always.
Yes. Why is this not double to float? Why?
Oh, it's var and because it's point 0.1,
Oh,
not
because
point 0.1f.
var is quirky.
Yeah.
Sure. So the added amount is always point 0.1.
You should try
So
if you're gonna add, do point 0.1 times time delta time. That way it'll add point 0.1 per second, regardless of like what the processing speed is.
I have delta
Right.
time here somewhere.
It's global. You can just do time dot delta time.
Okay. F times time delta time.
Yeah. And
Cool.
this is in regular update, not fixed update. Is that correct?
Yes. This is
Okay.
a regular update.
Yeah. So this should make it so it'll just add point 0.1 per second to it. That way it won't just instantly, in 2 frames go by and get everything
0.5 per
messed up.
second.
Got it.
So we set the pixel there to the added amount plus the old pixel. And the old pixel's heat was whatever,
Hmm.
dot R.
Which is gonna be 0 if there's nothing there
Yep.
before.
Yep. And the added amount, which is point 0.1, or point whatever, times delta time, times the target temperature,
Hmm.
times my capacity. I don't know, does it work?
Let's find out.
Oh, but I need to look at heat though.
Bloop.
Mm,
That's some hot steam right there.
that's some super hot steam. So
It's
it's the
point 0.8
correct
for lava.
temperature. Yeah. 0.2 for dirt. 0.2 for copper. Wait, but oh right, because now there's like an infinite amount of material there.
What do you mean?
Because I have no cap on the amount of material.
Oh, you uncapped that?
Yeah, I mean just straight up, just adds.
Oh, right. Yeah, you can keep sticking it on there.
Yeah. Um, but that's kind of working. I mean,
Hmm.
so this is not
This water.
exploding. This is also not exploding. Why is this not exploding anymore?
Yeah, what happened?
Oh,
I thought
because I wasn't using left click. Was it left click?
yeah, left click was your single dot or single point.
Oh, yeah, that's because I wasn't looking at heat.
Oh, okay.
So that's heat. Water still exploding. Lava still exploding.
So much heat.
Ridiculous amounts of heat. As it's falling, it's 10, 10, 20.
Yeah. But then as it stops, then it so it's got to be because as it's falling, it like, stretches out, right?
Yeah, yeah.
So it has to be something to do with the heat to temperature conversion. Maybe even in
Mm-hmm.
the shaders because it's the amount of material in that location is going down and that's making the temperature go up even though it shouldn't.
Like, did I just accidentally have it right when I didn't have
The
the
capacities.
height in there, and it was just divided by average capacity?
You could try and remove it all.
Yeah, I did.
You did?
Wait, no, I didn't. I don't even know. So this is the amount of water
Yeah.
times the capacity of water divided by the total height at the end. So this is a weighted average, and
Hmm.
it gives you just a capacity. It does not give you any type of amount.
Right. Yeah, because if you didn't divide it, then it would. So, okay, so there's a, I mean, this maybe this doesn't matter, but there's a slight difference in these things. Like if so if this max takes small,
Yeah.
then when you multiply it back over here, it's going to be smaller than the value you calculated, right? Like those two things are different.
True.
So, well, what you could do is you could say instead of average capacity, you could just not multiply or not divide by the height,
Because then I wouldn't need to
because then you wouldn't
multiply
need to
it by the height
multiply.
again.
Yeah.
All right. So that means those go away,
Uh,
and these go away again. Let me just do this.
Right.
Whee!
Undo everything. Because then
All
you
right.
just need to rename those things to like average capacity. I don't know what that's
Uh,
called. Well, I
it,
guess you'll rename it in a second.
it's the divisor. It's not a capacity anymore. It's a
It's a
weighted
it's a
amount.
yeah, well, it's a capacity times a amount. So it's like
Yes.
I don't know what units that is, but it's whatever units that is. I mean, you could just try it,
Uh,
right? Because the calculations now have the information that they need.
yeah, but naming is very important.
Okay, of course.
Uh, so I was originally, I think I was calculating specific heat before, and now I'm calculating total heat. So I had the specific heat capacity of 1 mole of the substance,
Hmm.
and now I have the heat capacity, which is the measurable ratio of the heat to the temperature change.
Well, there's something weird here, right? Because if you add water to lava, or just thinking about it elementally, if you add water to some other element,
Yeah,
um, you the heat capacity doesn't go up. The heat capacity becomes the average,
I mean,
right?
heat capacity will go up.
Well, I mean, I guess if you have more elements in that location.
Yes,
Okay, so right, because we're treating each pixel as a bucket of different things.
yes.
So as you add more material, then that makes sense. Okay, so this is actually like capacity, it's capacity times material. So whatever that is.
I think it's just called capacity
So instead of like,
because it was instead of because I'm misnomering capacity as specific capacity.
oh, I see. So the cap steam is actually specific cap steam, for
Yes, so
instance,
these would be the specific capacity of water
hmm which are per unit.
times the water. Yeah, per unit
Yeah,
of water gives
gives you
you the
the
total
actual capacity.
capacity.
Okay. All right, so
So it was right
that's
all along.
it was right all along, other than that dividing.
Yeah.
Uh,
So where else has that changed? That was changed in the world shader. No. Yes? No. Heat shader 2.
so
What else
average
has changed?
capacity,
In this here,
this
yeah.
those things are now those the heat pixels, G and B capacity, the capacity and conductivity. Is that still the average,
So this
or
is
is it a total?
the conductivity here is the weighted average of the specific conductivities.
Right. Which where is that used?
When you are conducting in,
Which is the other shader, right?
no,
Oh no,
it's here.
it is this one.
Yeah. So like this
Got it.
this isn't used in a different shader, but
Okay, I see.
then again, neither is this one.
Right. Oh, but conductivity is per unit.
Yeah.
So this is actually fine
Hmm.
because yeah.
Okay. So I'm gonna have to call up Git
Yeah.
and figure out what actually changed. So there's the amount that we changed in the main script. There's the heat2 shader, which we have this get heat flow. Did I save that? Save. Yeah, no, it's still there in the get heat flow.
Oh, I think we just didn't update that function yet.
Yeah,
Wait,
sure.
hold on. Oh yeah, yeah. You committed those the changes from before.
Hmm. So in wait, what? Okay, Tortoise Kid is just having a
It's not having a good time right now.
source tree.
Hello, source tree. Just pull up one right after another. Yeah.
Heat flow.
Okay. So the amounts went away
Yeah.
because you have the total capacities now, and you're not dividing
Yes.
by the totals anymore.
Yes.
Okay.
The temperatures are no longer with the heights because we're doing total capacity.
Mm-hmm.
Same thing for the call, same thing for the end. In the main script, it's just the added amount. World shader
It's
is
just
just
scaling
a
differently.
is just a display issue. So this should work.
We need to keep track of it. I need to keep a little counter that's how many times we say this should work.
I mean, the answer is a lot.
Yeah.
So can I just keep adding heat infinitely? I'm not sure.
I think you
So
limited heat, right?
did I?
Didn't you? If you're on the heat. Oh no, you're on the heat.
Oh, on
Right.
the heat
Never mind.
list.
On the heat
So
on the heat list when you're adding heat, then yeah, no, it's not going to be. It's if
this
you're
so
placing
the
one.
mouse 2 is unlimited. So this one, yes,
It's
give me
getting so
more heat.
hot. It's getting so hot in here.
14 heats.
On that pixel.
Yeah,
Look at that
all
pixel
right.
go.
So copper is a thing. That's point
Okay.
2.
Hey.
Dirt is a thing. Is also point 2. Lava is 23. Steam is massive, and water is plays nice until you click and drag.
As usual.
As usual,
What if you don't drag? What happens? That's lava.
Steam still freaks out.
Steam still freaks out. It's like, is it a directional
It's
thing?
it might just be moving too fast.
I'm
It
wondering
also
if
might be
there's
directional.
a one frame difference or something that's causing this issue.
Hmm.
Could that be
Well, so
it?
that would be in the pre. So this all runs pre-blit
Hmm.
and puts it onto the heat texture master. This puts it onto the flow texture master. And then here it always starts with the zeros.
It always starts with the master and goes to the, yeah.
Does
So hold on,
it
but it flows first and then it does the heat.
in this loop? Yes, but not the so the additional heat that we're adding and the additional amount that we're adding are all done before that.
No, no. Okay, so hold on, hear me out. So go back to that other piece.
Yeah.
Okay, so the heat texture, this heat material,
Yeah.
wherever this one down here, this heat
Yeah.
material references the height textures from the other thing, right? Or
It
like the material
references
textures.
this height texture
Yeah.
and these updated flow textures.
So the up the flow textures, because so this blits the results back into the master
Hmm.
as soon as, so like let's say you have this pixel here, right?
Yeah.
So when steam flows, it's going to flow up to here. It's going to go up one. So this is on master, this is on the new one, right?
Yeah.
This is
Hmm.
so it's going to flow upward and go over to here.
Yeah.
But then the heat texture is going to come along, and so this thing gets stuffed back into here. This is
Hmm.
overwritten, but
Yeah.
on the heat texture, then you now have your heat still down here, right?
Yes.
Because this is, and then but you have the new values up here.
True.
So you have a bunch of heat down here with no material left in here because it all flowed out.
True.
So maybe if you just take this and do it later, then it works.
Well, so this whole reason, or that whole thing is the reason why I have this shader because that updates. with the flow of everything where the heat went. So I have this pixel and it goes up here,
Hmm.
and I have the heat pixel.
Right. Hello?
Hello.
You just dropped for a second.
Okay,
Hold on.
this is weird.
I know. Team viewer's coming back, I guess.
My screens are still black.
Wait, your screens are black?
My screens are both my monitors are black.
Okay, that's not great. Did you get a power outage or something?
No, I hope my graphics card didn't die.
Yo, that would suck. I can see your. Hold on. Can you move your mouse? Yeah, I can see your mouse moving. Can you see your mouse moving?
I can't see. No, my monitors are off.
Well, that's weird.
Yeah. So
All right, we're gonna take a quick break and figure this out, and we'll be right back. All right. Drawing two boxes in paint broke the internet. So
Hmm.
that's clearly what it was. All right. We're back. So where were we? Uh, you were describing to me why the update order for heat was actually correct. And it's not what I
Yes.
think it is.
So there are two boxes,
Yeah.
or two cells, and there are two
Hmm.
heat cells. And when this one went up, oh, that was actually a pretty nice
That
ending on
was
the arrow.
really good there. Look at
uh,
that. Let's take
it's
a
all those
moment to
effort.
appreciate it.
All those first-person shooter games are finally paying off. I could draw arrows on stream that look slightly correct.
There you go. Precision.
Hmm. So anyway, so the heat or the element flows.
Hmm.
There's now no more element here,
Right.
but the heat still thinks it's here.
Right.
And so the code, so what ends up happening is that by no more element here, I mean R equals 0.
Right.
Green, which is northern flow, equals I flowed up some.
Hmm.
In fact, I flowed up the whole amount.
Yeah.
And when this heat shader, neat, it's the neat heat shader,
The neat shader.
updates,
Yeah.
it reads the green here and subtracts everything. So this goes to 0. And this one reads that one's green and adds it here. And so it ends up with the element flowing and the heat flowing together.
I see. Okay, so stupid question time. What if? Hold on, bring your little picture back. I want to draw on it.
My picture, uh-oh.
Oh, did you? You killed the picture.
Oh, quick pick.
Oh,
Oh, they're angled. Oh no.
can you activate the whiteboard?
Oh, sorry. Yes, whiteboard is on.
All right. Thanks, buddy. So, okay. So, stupid question time. When it removes heat and goes here,
Hmm.
and so it's heat's flowing out of here. What
Hmm.
if this amount minus the amount of heat that flowed is very, very small?
Then it goes to 0.
So, well, what I'm saying is like, so if there's, so same thing, if there's like a tiny amount left over here and some heat left over here, then it could
Hmm.
cause the temperature here to just go way, way, way up, right?
Yes.
So maybe is that what's happening with steam? Is there any chance that that's the case?
Could be. Probably is. Clear the whiteboard.
Yeah, well, you don't want to deal with
Let's
my drawings all
find
over your
it.
screen?
I mean, not really, but
Because if it's not entirely,
so
if the material or the temperature isn't entirely removed when that happens, or if it's like
yeah.
slightly different.
So this
Yeah.
only so if the height is greater than small, it does all these temperature and heat calculations. Otherwise, it sets heat equals 0, temperature equals 0, everything equals 0.
Hmm.
And in the flow shader, if this pixel is less than small, it has no more element in it. But, what happens if I do this?
Oh, it also, if it's small, yeah, set it to
I
not flow.
don't think these are right because this,
Well, it could cancel out from different directions, right? Like if it's flowing out, up, and then in, down, or whatever.
yeah.
So you know what I'm saying?
Well, so the point of this with the R
Hmm.
is that if like 99.9% of the flow flows out,
Hmm.
then this is going to be less than small.
Right.
But we still want to keep track of the fact that we did flow 99.9% out. Otherwise, the one above it won't update
What?
correctly. But we can try it out. Let's see what happens.
So I think what's, no, yeah, let's just try it. But I think what's going to happen in this case is if heat's flowing through a pixel, then it's going to freak out basically.
Um, I mean, it's kind of working, but it's millions
It's
of
like,
degrees and
yeah,
increasing.
I think it's because heat flowing through a pixel, right? Because you're updating this one's G, but that you're still reversing inward north or inward east to get the outward for the other direction, right?
Yeah, so you can't
Yeah,
update
so you
those.
can't update those. So, okay,
Intuition's correct.
can you humor me? And
Yeah.
instead of doing this if statement, so if is less than small, like just what happens if you don't do these? Like you just say, yeah, so don't do that one, and then also don't do the one in heat. So like just say if true up at the top.
Or hip, hip. Or wait, oh, right, because you want the other one to run all the time.
Right. Yeah.
Alrighty.
Just in case there's some sort of, edge discontinuity in that special case.
There probably is, because that's where you're seeing all the stuff. Steam, up. Oh, wait, we need heat on. Steam, what?
What in the heck?
That's interesting. Super high temperatures.
And it's not flowing with the did it
Nothing is flowing.
did I break something else? Like that should
Uh,
be it should be flowing all the time, right? Isn't
mm-hmm. Unless,
huh.
is it too small to flow? No.
So why would why would it do that? That's really bizarre.
I mean, I can also change here the highlight from temperature to heat. You have a better idea of what it's actually doing.
Mm-hmm. Oh, because we can sample the temperature just by mousing over it.
Yeah.
Okay.
Huh. So that's what it looks like with heat.
That seems right. Well, no, that doesn't seem right. It gets randomly really hot sometimes.
Yeah. It's the mousing thing. Huh.
Dang.
There's not a disconnect between the mouse position because it's only sampled once, right?
Yeah.
Right? Right,
Uh,
Unity?
it is. Yeah. You're only doing it one place, I think.
Um,
So it is an update, and the textures are all the same size, so it's not like you're updating them, like updating different pixels or anything.
yeah. Yeah, because like this only happens once.
Hmm.
Then I have pause grid for the whole thing.
So, man, I really feel like this is an off by one frame thing. I don't know why, I just get that intuition.
And so I can take out the multi-update sequence.
Oh, like say, just update one at a time.
So that's once per frame now.
So it's gonna be just so slow, right? Because it was at like
Maybe.
2000 before or something.
Yeah.
All right.
Uh, I
Is it so slow it doesn't even do anything?
I don't
Wait,
know
hold on.
what's
Repixel.
happening.
Oh, you have to restart. You're getting an error in the Unity console.
Oh, yes, I am. Very true. So there's some lava. Heat says no.
Huh. Okay, hold on, hold on. You see something interesting there?
Mm, maybe.
So when you dragged it across a place that already had some stuff in it, that's when it got crazy temperature. At least I think that's what I saw.
It seems fine.
So you're drawing, what were you drawing there? Lava?
Yeah. Steam just works straight up. Everything is crazy all the time. But only the
S-
top half is crazy.
So when you do the steam, do it again. When you do
Hmm.
just steam, it looks like when the steam flows up into itself is when it builds up. You see, because it's just above where your mouse cursor is.
Yep.
So there's something about when it's like maybe a cascade of heat, and so that's why I'm thinking it might be an off by one thing because as like if the heat propagates up one one pixel with the flow from every single pixel, but then adds to the heat that's currently there, then every
Mm-hmm.
frame when it does that, it's going to be stacking heat on top of itself until it hits, some super high temperature. Does that seem right?
Okay. So what happens don't do if we don't do flow?
Oh, I just don't flow the heat at all.
No, and just move with the heat.
Oh, you mean, okay, hold on, remind me. Flow is the conductivity.
So there's the movement,
Hmm.
which is move with elements, and there's the distribution. So if we don't do distribution
Right.
and we only do movement,
Hmm.
what do?
Oh,
It don't matter.
so that's the thing that, well, potentially that's the thing that causes it. What if
So
you
this
just
is
do,
just movement.
yeah, what if you just do the conductivity and not the movement?
Uh, then
I mean, we should.
it should not actually move any. So unless you put heat in an object,
Mhm. It's running super slow, but yeah.
yeah, but this will distribute, but it's not actually going to go with the
Yeah, it's not
steam. So
actually
when I
going to
have
flow with
steam
it.
here, you can
Yeah,
see the
it'll just
heat
get
created.
right. It kind of flows a little bit, but not much.
Well, yeah, it distributes a little.
Or distributes, right. Yeah, it's not going to flow with it.
Yeah, but yeah, so
It's definitely something to do with the flow.
it's definitely the
I
yeah,
mean,
sorry, yeah, the movement.
right. And
So
so
this section.
it looks like what it appears to be doing is it appears to be moving more heat than exists, right?
Okay. Hmm.
So why would it do that?
So in every one of so this begins at the flow shader
Hmm.
with this equation.
So this is
So this is
getting
the amount that is flowing.
right.
Um, this is calculated here.
Hold on, go back to their height, their amount. Where you call this again? Oh,
Here.
okay, height pixel, heat pixel. Well, I thought you might have passed height pixel or heat pixel twice, but it's not.
Mm.
Okay,
So
so
this is
it's
heat height
heat height. Yep.
for heat
Heat
height,
height.
heat height
Okay, yeah.
for get heat. So does get heat here make sense? The flow divided by the height gives the percentage of total height. And then you take that percentage times their heat. This is where I was saying that maybe I need to add capacities, but
Hmm.
that would be boring. Instead, now we're down this tangent, which is great. Uh, and once you get that percentage times the heat that would flow, that gives you your heat amount, and then that's your heat in amount.
That's a negative min heat amount out. All right, I need to look at this for a second because doing all these like mins, maxes, negatives always
Mm-hmm.
breaks my brain a little. So
So this is flow. It should be flow in.
it's flow. That's flow into this cell from the direction of from their direction.
Yes.
Okay. So percent flow in is the percent of their height that gets flowed into here,
Mm-hmm.
and percent flow out is the percent of my height that flows that direction negative because flow will be negative since this is an in.
Mm-hmm.
Okay. And the percents of all flow in the case where something completely leaves should be 100% because it's my height.
Yeah.
Okay.
Yeah.
So figure out how much will actually flow. The heat coming in is you just take a percentage of their heat
Yep.
and you flow that.
Directly proportional to flow.
So in the case where you have multiple elements, well, no, this occurs with single elements, so that's we're not going to worry about that. Okay. Heat in percent flow out is, hold on, percent flow out is always positive.
Should be, yeah.
Doesn't this, oh, it's always positive or zero. Okay,
Mhm.
I see. So then, right, heat amount in, percent flow in is always positive. So it's times their heat, my heat. Heat in is the maximum of the amount that is a percent coming in from them minus the heat amount out, which this min is kind of redundant, right?
Yeah, it is.
But,
So this min and that max should be able to be taken out.
right. As long as, so as long as flow is never more than their height or my height,
Mhm.
do we know that that's the case?
Right, so that's what I was going to check, or not check, but change
Hmm.
for steam, solid, steam. Oh, no, that's not true. Oop, fixed.
Wait, what was 4.5? What is this number that you're doing here?
This is a flow divisor, so assuming flow in every direction,
Yeah.
I mean, we can also update this. So
Oh, right,
it
I
would take up
remember.
maximum that much of the thing, and with 4.5, it can take, if it flows in every direction, it can take more than there is.
Hmm.
So that's interesting.
So it's like it's creating heat on the top half of it or something.
Hmm.
Wait, are you doing just a single point heat creation or is this an area one?
So
Or
the super screwy ones was a area, but this is the point heat creation.
or the point material creation?
Yeah,
Yeah. Wait, is that just
which looks
working over
stupid.
there? What's going
Yeah,
on?
which is just straight up working.
So the area one is the one that screws things up.
If you click and drag, or is that also just working now because there's so much steam? Oh, heat. Yeah,
Huh.
but if there's like 0.001,
What it looks like is, yeah, if it's flowing into zero, then something's screwy. Try doing the single point one in that second column there where you don't have anything yet.
this is fine.
Okay, the single point one's okay. And then as soon as you have even a little bit of stuff down there,
Hmm. But no, the
well,
so it
no.
didn't work for the area one.
Hmm.
Hmm. Did I just not do the area one correctly? Place lots. This is in a for loop.
Mm-hmm. You're doing different pixels each time.
Pause grids are really getting and setting different pixels. Yeah. Hmm.
And you're, yep, okay. Additional heat techs.
Mm-hmm. Let's see if we add slower. What happens?
Well, yeah, I don't know if this is going to do anything.
Are we sampling heat now, or are we sampling temperature? I think
Or
we're visualizing heat.
you're visualizing heat, yeah. Oh, right. Yeah, we should. And we can also look at the little indicator. Holy cow.
Yeah.
So empty space has a bunch of temperature.
as a bunch of temperature.
I mean, this looks really cool, but I don't
Uh,
think this is
it,
what you wanted.
no, not really.
So does this mean that it's leaving heat behind or material?
Like, yeah, a little bit of residue.
Oh, which of
Something.
course it is, because remember we took out those if statements that decay things.
Right. That's true.
So okay, so this is incredibly hacky, but what you
Hmm.
could do is oh man. Okay, so what I was thinking is like you just make heat decay over time if there's,
Hmm.
or make heat decay and material decay over time, but obviously that doesn't work if you want things to be stable.
Yes, that's true.
So lame.
All right. Um, so where are we at with this? What are our discoveries?
So the big one is that heat flow is causing some sort of issue that causes heat to stack up on top of itself,
True.
right?
Hmm.
But we did do that experiment with the if. So if you undo that, then maybe that prevents the temperature from just kind of hanging around behind.
Which was in the heat shader
Yeah, this heat shader is this one, and then there's also, I think, in height
and the
shader
flow
or flow
shader.
shader. Yeah, where you might just be able to
Uh,
control Z this one.
uh, yeah,
Yep.
did it.
So maybe that fixes that. Well,
But
this is
also
just,
these,
I mean,
yeah,
that thing.
that's
Yeah,
just optimization.
it's equivalent. Yeah. So maybe that makes temperature not get left behind.
Temperature, lava, steam.
It's some
It's
hot
very,
steam.
it's very hot.
Yeah, 40, 40.
Yeah.
I mean, it looks a little better than it did, but
Mm.
look, do you see that heat transfer that occurred there? That's pretty cool.
Yeah, and you see it flowing through the lava
Yeah.
as well.
Okay,
Neat.
that's pretty cool, right?
Yeah, it's
How hot
a
is the
nice
lava?
cool. Uh-oh,
Oh, but water's still getting little
water gets wrecked.
blurps there. Yeah.
Yeah. Why does water get blurps?
Is it little bits of heat left over from something else? No, because you can get it with just water on its own, right? Like if you stop and restart this and you just use water.
Yeah, I can just put water in a
Oh,
colony.
right. Yeah, of course. Okay.
But
Dang
yeah, I
it.
think something to do with a very, very small amount of.
Yeah, I think you're right. We could probably use another visualization for that.
I mean, I could up small.
Hmm. Maybe. Try it. The value of small is now larger.
Hooray! And heat 2, I think it needs to be greater. And this just starts clipping
Yeah,
everything.
it's gonna clip very aggressively here.
Mhm.
So
Please,
aggressively, in fact, you can't add any material to anything.
please to the lava. Yeah, okay.
Small might be too
Uh,
large.
the small is now very
Well,
large.
because when you're adding material now, you're multiplying by delta time. So if you don't multiply by delta time, then it'll do it.
Right. Okay, let's try that. Per frame.
Yeah, your
Restart.
your single pixel add is just gonna go insane.
I hope so.
I mean, it'll add 30 units
Boop.
per second. Oh,
Where'd it go?
bye.
Oh, that's as far as it can get before it gets to the clip limit and just
Yep. Yeah, as it
collapses
starts
in
to
on
spread
itself.
out, yeah, it just kind of dies.
Yeah, but these are the right temperatures.
That's good. All right. What about the massive Steam edition?
Yeah, it's the right temperature.
Huh. So you're right.
So
I mean, this would suggest that it's some sort of close to zero problem.
I mean, it looks like a tuning issue to me now.
Just kind of fudge the value of small until it works.
Yeah, isn't that all games are?
Yeah, just get it close enough and it's good. If the problem would be if it's frame rate dependent.
Yes, that would. So this is no longer corrected value. No,
Yeah,
400 seems like a not correct value.
it's a little large.
So tune that back up again.
Just go by orders of magnitude. It's fine.
Yeah, doing a binary search.
Yep, over the space of logarithms.
Uh,
Oh, but now it's
Probably
evaporating.
it
Yeah, you
won't
can't
ever
solve
go
it.
anywhere.
Yep, because you have to have small values in order to get it to flow.
Yeah. So super, except when it's not.
Yeah, because it just gets slurped up by the universe.
All right.
Well, I guess we
So
can't
small.
solve it that way.
No, small is now small again.
So, okay, remind me again, humor me here.
Hmm.
Why is there both heat and temperature, and not just temperature?
Uh, because heat is absolute.
Heat is absolute. What does that mean?
Temperature is a concept.
Okay, heat's the physical value.
Yeah.
So, but then is it because of mixing heats when you flow into a new pixel? Because I'm trying to remember why, because it seems intuitive that if a heat, if a piece of material flows, it stays the same temperature. And then
Hmm.
because it seems to me like potentially the temperature problem might be coming from, oh, well, I flowed this amount of material and this much heat, and then the calculation to and from heat is the thing that's causing it you know,
But
to get
see,
slightly
that's
out
the
of
thing.
sync.
It's like everything works when you're not placing heat at the same time as you're placing material.
Hmm.
If you run material into heat, everything flows, everything distributes. If you put heat onto a material, everything flows, everything distributes. But if you introduce at the same
I
time
see.
a flow and a material, it no
Yeah.
longer works.
So what if we did an experiment? Is this so instead of placing heat at the same time, can you
Hmm.
go back to replacing heat separately and then we place like a big block of heat and then stick steam on top of it and see what happens?
Yes. That would be in the main script. I take out for Steam, inflating the additional heat text. And then here,
Just gonna place some heat in empty space.
I could place some heat in empty space, and it should be there by magic.
Yep.
Oh, or it's not, because it gets culled by the height. But if I put heat in it,
Is that
heat
okay?
is
People,
flowing faster than the steam or with the steam. I don't know.
it should be flowing slightly faster because it's both spreading and flowing, right?
True-ish.
So
Steam heat.
what
Steam heat.
temperature is that though?
Massive. This is interesting.
That seems right actually because it's not crossing the center flow, like because those things are flowing apart from each other, right?
Yeah, but with the distribution, it should distribute to the right.
Yeah, it should, at least
Well, I guess
slightly.
eventually.
Yeah. But this is also being run very slowly.
True.
And the conductivity of steam is pretty low, right? Wasn't that true?
Yes.
Yeah. So if you're flowing copper, then that would probably be more likely to happen.
Yeah.
Are you placing heat?
No, this is lava.
Oh, it's lava. Okay.
It's as a test to see if heat distributes in an element. Looks like it kind of does. I mean, yeah, I could just straight up place heat in dirt, but it's never going to go anywhere.
Right, because the conductivity is so low.
Yeah, that's
Yeah.
totally going somewhere.
Yep, that's working.
Cool. But steam, lava. Wait, what were we testing now?
Just testing to see if, so when you place them separately, it seems to work.
Yeah. So now steam is taking all of lava's
It's
heat
taking
with
his
it.
heat. Yeah.
Yeah. So as the steam flows through the lava, it
Yeah,
sucks
that
up
looks
all
right.
the.
And then lava is just down there with no heat. Poor
Yep.
lava.
Hmm.
Which that's correct based on the settings because steam has a higher capacity.
Uh,
Yeah,
maybe. Yes, it does. It has a two capacity,
yeah.
and so
So
now they
it's
should be the same temperature.
what the
This is
lava and
point
the
0.2 and that is 0.5.
they should be
Yes.
they should end up being the same temperature if the conversion's working properly.
Yeah. So if I have lava and I have steam,
And we're looking at heat, right?
we're looking at temperature.
Or we're looking at temperature. So they should end up
Yeah.
being the same color.
Maybe.
I mean, as long as the mixing has
Yeah, as long as
occurred,
they mix. Yeah.
right? Which I guess if you put them in a container and just fill up the container with both, then that would be the
Mm,
indication of that because they're flowing past each other right now, right? So they may not be in
yeah.
contact long enough for it to matter.
But that's going to take forever. Dirt. Hollow out some dirt. Steam. Lots of steam.
Yep.
And lava.
Okay. Now those two should come to temperature.
Yes. I mean, like, I'm pretty sure we're looking at. Wait, yeah, so main script, I have some debug text. That debug text is outputting me output values text,
Hmm. Which is
the
the heat,
temperature. It's a
which is
temperature.
the temperature.
A.
Wait, on heat textures?
Heat textures contains
Oh, dot A is
both.
the temperature. That's right.
Yeah. So here we have the
Yep. Temperature
RGBA,
in the alpha.
which I think this is true.
Heat over the right average capacity. Yeah.
Yeah.
Oh, but
So
we're only running one step per frame right now, so that's going to resolve really slowly.
yeah, I mean we can up that again.
Yeah, we probably should, at least for this test.
Which is another test that I tested before changing the way things were calculated. But that
You
seems
test
to make
you
things
tested this?
worse. Yeah, I checked it. Like, do things come to equivalence?
Huh. Maybe we
I
just need to
thought, at
revert
least I
what we
thought I did.
did.
I don't know, but like that doesn't make sense to revert what we did because we did the right thing.
Yeah, I know.
So steam goes in there, and lava goes in there.
And those two things being touching.
Like for realsies.
Hello?
This is yeah, okay.
It's going
This is
up.
yeah. This is going down. As is this.
0.08.
But I thought we were looking at
We're looking at
we're
temperature.
looking at lava. Now we're looking at
Oh,
temperature.
okay. There we go.
So why is this so much hotter than this one? And it's still going down.
Yeah, that's not right.
You know what?
Are we
This,
reverting?
this sounds like a revert.
This sounds like a revert because we made something worse.
Yeah.
Man, that sucks.
What
Okay,
do?
I don't know, man. So we fixed this. What did we fix? We fixed the
So this is what we did. The main script, the flow divisor,
mhm.
changed the added map, and commented out a blit for
Is that all?
steam
Well, that's all we
for the
did since
heat
the last
input.
commit, But
Since the last commit.
what did we do in the last commit?
Ooh,
Because I'm
well,
wondering if that messed something up too.
this one.
Yeah. Okay, so this was just adding the. Oh, right. Okay, so here we had. This is another piece that we reverted, right?
With their amount, which we should revert maybe. So
Yeah. So
this is my last.
let's go all the way back to here, and you might want to create a new branch just so we're not working on a detached head.
Yeah. Stop.
Unity's freaking out. It's like, oh god, you changed everything underneath me.
I did. Yes. Okay. So, branching.
Yeah.
What?
It's the perfect branch name.
It's the best branch name.
What? Oh my god. What's happening?
So, where are we with this one? With this one,
Yeah,
I
let's
mean,
see
I
if two
hope.
things come to
Do I have
temperature.
uncommitted? I don't have uncommitted. Okay. So, first of all, what are we viewing? In the world shader, we're looking at temperature. So here, this is temperature.
It's a nice little temperature there.
Yeah. And oh, I don't have my nice debug output.
No, you don't.
Uh,
You go
no,
grab
this one.
that.
I could go grab that. Put some heat in the lava. And it flows in there. Have some steam. Put some heat in the steam.
And it flows up
Goes
there
in there.
nicely. Yep.
I have a box of dirt, or rather of not dirt. Go away, dirt. And I have some steam and some lava and some heat. And I crank up the speed. Oh,
Yeah.
these don't look to be the same temperature.
No, they don't. Hmm. That looks like a commit. Wait, what?
Wait, what?
I thought you showed this earlier though. I mean, well, the heat
I did.
flows nicely.
So I had lava,
Hmm.
and then I added heat to the lava,
Right.
and then I had some more lava over here, and
Yeah.
some more lava over here.
Yeah. And those
And
things that flows through correctly.
when I have copper, and I stick copper in there, it flows through the copper.
Yep.
If I put copper into that one, and I heat this up even more, it flows through the copper into this one and heats it up.
Yes.
And then these three will come to temperature.
So why on earth do two elements right next to each other not come to temperature? Or is it just steam?
Well,
Like, can you do that exact same thing but with steam instead?
or how about with water
Yeah.
and lava?
Oh yeah, good point.
Because maybe if you heat up the lava a lot and it goes through the wall and conducts to the water, they don't actually reach the same temperature. Let's put in some copper
Oh.
to help them along. Survey says maybe.
Well, it's going to take a
Well,
lot more heat to heat up water, but they should come to temperature.
yep, maybe, approximately. I need my debug.
Oh yeah, I gotta go grab that.
Yeah, gotta go grab the debug. That was a good thing.
Yeah.
Which was,
Did you save that piece?
I hope so. No.
No, you just
Nope.
reverted all the.
Yep.
Oh no.
Get wrecked. I didn't commit before I switched.
Wait, if you
So,
did commit before you switched, you should still have unchanged files. Or did you
right.
revert? Did you revert all those?
I don't know. I think I like clicked a button. It said get wrecked.
Uh-oh. Yeah, that's the get wrecked button.
Yeah. So here's my debug text. Plus additional text. The additional text to grab the render texture from heat texture.
Don't you love writing code a second time?
Yes, I love it. It's great because I do so much faster. And then you take that text and you get a pixel
Yep.
from var pixel is the x and the y, and that pixel additional text equals pixel dot. That is the temperature. String. Cool. So
Noise.
doodly doop, boodly boop, shibbly bop.
4?
Hot. Oh yeah, it's hot. Just adding the heat
Got it.
blindly.
So much heat. Is there a cap on the heat that you had this time? In this version there is, right?
I don't think so.
There isn't? It doesn't like add to a limit?
No, it might, but that's not a cap on the temperature, it's a cap on the heat.
Oh, right. Yeah. So I guess it depends on what
So,
materials are there.
yes,
It's,
it
yeah,
is.
capped to 0.5.
Yep. So this is some temperature.
Mm-hmm.
We have water, and we have lava, and we have some copper in between, and we add the heat over here.
That looks good. Now they need to come to the same temperature, though.
That's the question. 6,000 speed.
Is that updates per frame?
Yes. Are we still running at full frames? Yes, we are. Maxed out frame rate.
Holy cow.
So yeah, these are exactly the same temperature. Everything here is exactly the same temperature.
Well, then everything's good. Except for the ability to add heat at the same time as material.
But why?
I don't know.
Why does it work? I don't understand.
Oh
I
my
did it right the
gosh.
first time, and I don't know why.
I don't know why it works either.
But you know what? It should be a simple thing, just to add default temperature on element placement, right?
Yeah, we just do that and then we get right on to this next piece that we were gonna do.
And look, we have that. We have that as a commit. Which that branch?
Oh gosh.
Because okay, so what do we do with this one? We added, but this is where we did that amount stuff, which is apparently a mistake.
Yeah. So getting the amounts in there actually screws things up.
Also, these are mistake. That's mistake too, as well as that. So on the main script, this is the cap because we needed capacity in here.
Mm-hmm. Oh, because we were setting a target temperature and not a target heat.
Why don't we just set a target heat?
Because
We
then
can calculate what heat it should be based on the temperature by ourselves and skip the computers that do math for us.
okay. Target heat done.
I think that might be the answer. Okay, so
All right.
simple mode.
Mm-hmm.
Here, we know we have to get a added heat text.
Wait, added?
The added heat text, because this is work with me.
Okay.
So the added heat text is something. Yeah. And that added heat text, oh, we need to change our render texture first. That's why. Change render texture.
Right.
Yep. So now we have an added heat text. And when we're just going to skip that. We're only going to add heat on this one because it's easier.
Yep.
And that this added heat pixel is
You're just gonna copy pasta exactly the same thing.
Pretty much.
All right,
added
cool.
heat text set pixel at that some stuff.
Wait, don't forget to change your other pixels, like temp G, B, and A.
This?
Yeah, the bottom there.
No. So this I'm deleting.
Oh, okay.
Is this? I'm just wondering. Is this added then?
No, it's absolute. isn't it?
It's so it's added to the okay. So this is the original R
Mm-hmm.
plus some heat.
Cool.
We're not gonna worry about those. Why is this wrong? Double the float. All right. And when we do that, we have to apply it. And after we apply it, we have to blit it. But
Always blit.
we could just do that here.
Yeah.
Why is this wrong? Okay.
Need another, yeah.
Yeah. All right.
You got it.
So we could just do that here. Oh, not there. There.
Don't forget underneath there in the blit, you got to replace text with added heat text.
In the blit, yes. If element selection I does not equal heat, not equal element selection heat. I don't really know what's going on with my braces there, but that's fine. All right, yeah, cool. So if
There
it's
you
not
go.
heat, it will
Yeah.
do it.
Looks good.
YOLO.
Let's see what happens.
Yes. So I'm looking at heat. That's heat. And I add some lava. Oh, wait, because, yeah, left click doesn't do anything. I have to middle
Yep.
click. Oh, God, it's heat.
Look how heaty it is.
It's
So
so much
heat's
heat.
unlimited. So as you add heat over an area, it's going to go up forever.
True, true. However, when I'm placing it all steady like, well, in theoretically steady like, it still has that same issue. Right?
Oh, you mean of like, yeah, increasing heat way too much?
Yeah. Only in certain situations.
That's really
Apparently.
bizarre.
If I move my mouse fast enough. Or it's steam.
Or it's steam. Well, because steam flows quickly, right?
Yeah.
Is that's the gradient on steam, right? That's doing that?
Yeah.
So just as
Sorry,
an
no, it's not the gradient.
no,
It's the amount per frame. But I can reduce that by a lot.
it's the amount per frame that's being added.
Yeah. So there's two values for every flowable element. There's
Uh,
flow divisor and flow gradient. Which, right, we fixed that.
mhm.
In any case, flow divisor and flow gradient. Flow gradient says at steady state, how much is the one above it? How much more material does the one above it have below than the one below it?
I see. Okay.
Whereas flow divisor is how much flows per frame. So we can just divide.
Oh, that makes it flow slower. Okay.
Yeah. So actually, you know what? We can just do this. Those are my three flowables.
Yeah.
And then do an extra 1,000 updates per frame.
Oh yeah, I'm sure that won't do anything.
Let's check it.
Yeah.
Let's check it because we don't know. Right, so currently we're at 600, so we just crank
Yep.
that up to 6,000. This should look like it's the same. It does look like it's the same. But on the heat, lava's still weird, and steam is
Still weird. Okay, good. Well, what did that tell us?
That
That
it's
means
not
it's
a per
right,
frame flow.
it's not a flow rate thing. It's an accumulated flow thing.
Yeah. So I can just go ahead and undo that.
Yep.
Which we want it to be 5 anyway. Or like 6, just for safety. So now when we do 6,000, it should be super speed,
Mhm.
which we like because sometimes we like having super speed. Oh, yeah, super steam.
Yep, super steam and super steam heat. It's just like a flamethrower. Yep.
Lava's just silly beans.
Yeah.
Water's still silly beans. All right, well, I don't know. The good news is we don't have to think about it because it all evens out in the end. And as long as you don't place heat at the same time that you place stuff,
Yeah. Then you're
it'll
okay.
work for what we wanted to do.
Well, so let's see. I guess where does that leave us for today?
Um,
Is this right back
we
where
could
we
start.
started?
We could start on the uh, whatever state transitions.
Let's do that. Let's start on state
Okay,
transitions.
let's do it.
All right. I think I got probably another 45 minutes or so. Does that sound good?
Okay,
All right,
yeah, sounds good to me.
let's do some state transitions.
Cool. First, I'm going to remove this stuff and the added heat text so that we can keep this additional text and commit it.
It's a baby commit.
It's a baby commit, yeah. Oh, that's okay. Sometimes you need baby commits. Added debug text.
Yeah.
Very important. Push changes. So how do state transitions work is the question.
Uh, well, you're gonna need an output shader for each one, right? Wasn't that
Mm,
wasn't that what we talked about?
maybe.
Because you can also do you said you could do it in the flow shader potentially, but then oh no, you wanted to do a like a single shader that took the different thresholds and
Mm-hmm.
I guess you create it from other materials like or other elements.
Yeah, so you have like an input element, output element,
Hmm.
or rather, yeah, you have an output element that is modified by the shader,
Yeah.
and an input element that is not modified by the shader. And
Hmm.
so you have to do two instances of the shader, one in each direction. So the
Right.
input output or output input.
Yeah.
And each one has a trigger hot, like a heating level and a cooling level.
Yeah.
So that starts with a material,
Yep.
uh, which for our viewers at home, I can put this up here.
Oh, there we go.
Um,
Oh yeah, you remembered.
so, yeah, so we have to copy those
Yeah.
and take this and rename it because this is no longer a flow material. This is a state material.
Nice.
Instead of the flow shader, rename it as state shader. So with these, they still reference not the right thing. So this is now our state shader. This will be states. Go back into the main script. To add a new material, we will need to add something like that. I
Hmm.
don't yet know if it needs to have a main and a next or so. So how is this going to work? We have, let's say, for example, the water
Hmm.
that we want to state transition into steam.
Yeah.
That means we'll take water as an input variable and we will output to the steam texture directly,
Right. And
which
you're
means we don't
never
even need a texture.
uh
We just need a material. An array of materials, but
mhm.
that comes later. So currently
Yeah.
we only have one.
You do need the two like the master and slave though, because you have to have you have to be able to read the value that is there before and then write a new value.
But you can do that in a single step with a null insert writing to a value
Oh, right. Yeah, yeah.
like that one.
Yep. Okay, cool.
So we have state change, the state
Hmm.
material. And so in Unity, we can go and directly assign that to our quad. Because now we have here the none material. We want state material. Oh,
It's
done.
in.
Hooray! So now it should compile, but it doesn't do anything yet. So let's just Control F that. Well, that kind of looks like what it needs to be. And we'll copy pasta all of this with I'm too lazy. State material is a new material state material, I guess. Oh, double check at Unity that state material uses the correct shader.
I'll use the shader.
Flow, 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 state.
Nice.
Very good. So now we have a state material. This is a change of elements. Well, change of state, actually. State of element slash change of elements.
Mm-hmm. Because you
Depending on
really
how you
just,
look at it.
yeah, I mean, you really just store them as different elements, right?
Yeah, I mean, you could change water into dirt. Like it doesn't. If you get water hot enough, it might turn into
Magic.
dirt.
You never know.
Yes, might be, might be. So this material has some properties.
Mm-hmm.
These are way too many properties. We don't need that many properties. So in our shader, what do we actually need here? We don't need a flow divisor or gradient.
Mm-hmm. Because you're not flowing at all.
We don't need a height text or a heat text, but we need an input or main text.
Wait, we need heat text, right?
Yes, we do need a heat text.
Yeah,
because we need to know when things are hot.
Right. And then main text is just whatever you're operating on. So that gets passed by the blit.
Yes. And this is the hot text as opposed to the cold text. Can this argument be null?
The cold text?
Yeah. So can we say like, so can we instantiate one instance of this with, okay, water, cold, hot, and another one with dirt, hot, but no dirt, cold, because nothing happens if it gets too cold? Or do we have to make two different shaders, one
in each direction?
One in each direction.
So you could do this with
or just one with a flag that says direction.
You can do that. You can do it with multi-compile, and you can make a flag that just says direction. So for now, you can write it as an if statement, but you can kind of compile shaders on the fly in a way that, like, if this flag is true, then it's just like using, what is it called, macros in C.
Okay.
But cool. You can do it using properties, which is kind of cool.
So in any case, we have an output text then. Whether it's hot or cold, it will be an output text.
Yep.
Output text, heat text, and what else do we need to know?
Wait. Output, isn't it input text? Because you have to output onto main text.
Oh, you output on a main text.
Yeah.
That's true. And this is the input text. Input. And we need to know our transition temperature.
Yeah.
Temperature. Or we could be more explicit there.
Nice.
So we have some transition temperature, which is apparently 0. And an input that goes to an output.
Yep. Cool. And also which direction it is.
Currently only one. It only goes hot.
Okay.
But yeah.
We can make it only hot first, and then we can add something to say direction after.
Yeah. So we're gonna make water go into steam.
Yeah.
So transition temperature is here. Text with text height, heat text, input text, input rex, input text. No flow divisor. And we're ready to begin. We have a main text set up here, which is good.
Looks good.
We don't need get flow or get heat. We do want to sample this and all pixels around it. Probably not all pixels around it, just this pixel.
Mm-hmm.
We want to sample the input.
Sample it.
Input pixel from the input text. That
Yep.
makes sense. Everything's making sense.
Yeah.
And we want to sample the heat pixels. I think I just
You just deleted that. That's good.
Whatever, man. It's fine. Optimal coding. There
Yep.
we go. So,
Working hard in
you
the
know
code
what?
mines.
Optimal coding? Ah, yes. Right back on.
Right back the way it was.
Very
Nice.
good. So, we have this, we have input, we have heat.
Yep.
We're returning this. I bet this compiles. So, this does not do anything.
Mm-hmm. You want to add it to the
And
main
we want
piece
to
and
run it.
yep, run it. Make sure it doesn't do anything. You're gonna be missing a bunch of parameters up there, right?
Am I? I am. That's true. So state material change this sets the pixel texel width, texel height. We don't need a flow divisor. We need a heat text. We need an input text. Input text is going to be water. Main text. Main text. Do we do it that way? Is that how it's done? I don't remember how to set
No,
main text.
main text gets set in the blit. It's whatever you're
It's the
writing
blit.
to. Yeah.
Right. All right. So we don't have to worry about that. And we need a float threshold for temperature transition.
I think it's transitional temperature.
Dang it!
Just
State shader, transition temperature. Very good.
yeah.
0.2, 2.0 F?
2?
Question mark?
Wouldn't you
It's
love
gonna
if
be
you could just
point
pass like it's kind of like this. You want to figure that out for me, computer? Like
I mean, that'd be great. Just try
just
something, try every
yeah.
possible combination with quantum computing, and then tell me the end.
Yeah, just let me know what happens.
Yeah. So we have some state material.
Yeah.
Great. It does some stuff. We scroll
Cool.
down a bunch.
Stuff is good.
We want to run the simulation with the flowables. We update the height map. We update this. Wait. We update the height map. When does this get called, and what do we have to do?
It's I mean probably post heat, right? Like you can run that
All right, so
last.
right at the end.
Yeah. Because heat's back in its master.
Yes. So we can blit. What is it here? It would be water or something. Flow textures 1, flow water 0. Yes. So here would be the
Flowing from water.
flows dot water 0. What am I doing wrong? It's an int. So that into, I guess itself? No. What's
Steam.
this is,
You're creating steam, right?
we're creating steam from water, which means we take water as the input, but that's main text.
Right. Water's main text. So
But this is main text.
wait, no, but
No, we
you're
want an
writing
output.
you're writing the output. Main text is the input that's provided in that parameter.
Yeah.
Right?
I don't know.
So main text is the one that's going to be provided as the first parameter because that's what you're reading from. And then whatever you return to is what's going to be written. So steam is going to be written, which means you need to provide steam as another input, right? Or no, is it steam on both and then input text is water? Is that how this is set up?
I mean, it can be been done different ways, I guess.
Yeah. I think that's how you
So,
intended to set it up.
so this is the state material.
Yeah, input text is water. Okay, so main text should also be steam because you have
Main
to
text
read
should
you have
also
to read the value off of steam, add the new amount of steam that you're creating, and then return the value so it gets written to steam,
that makes
right?
sense. That makes a lot of sense.
So then you got to use the two-part flow texture thing. You got to go from 0 to 1.
0, 1,
Yeah,
and
and then blit it back.
then lit right back. Yeah, I didn't think we discussed this on stream, but I took out all of the flip-flop because it was confusing me, and we can
Right.
always optimize later.
Yes.
Um, do state change for water to steam. To stemma. Steam.
Stemma.
Index 0.
Let's make that stemma.
This is not that, it's this one.
Ah, right. Why is my heat being all weird?
Ah! Okay, so this will modify some steam,
Yeah.
but is that okay?
Well, if you run it right now, it should do nothing, theoretically, right?
Yes, that's true. Right now it should do nothing. But so if we run it at the very end,
Hmm.
is that okay? So we got some steam, we got some water, we have heat, nothing happens, everyone's happy.
Don't you love
So
writing
when,
code and just nothing happens? It's like, yes,
yes,
nothing
yes.
happened. Yeah,
Nothing
I
bad
got
happened.
it. All
Yeah,
right,
so
state shader.
the state shader happens here.
Right.
For easy peasy reasons,
Hmm.
let's say this pixel is input pixel.
So every time you create water, you're going to create steam.
Yes, that's the problem. Because the steam will never go away, or the water will never go away.
Right. So you have to do another one. You have to build the one that's in the other direction as well.
Yes.
And in fact, you have to do both before you blit either one back.
Also true. So this is the water. Using the state material for flows.water.
Yeah, I guess you got to
Yeah.
make a material for each one. But it's a transition now, right?
Yeah.
So you can make a
So
new
this is a
enum.
new enum.
Yay.
Transition. No, stop it. Steam to water. Wait, no,
Perfect.
this is water to steam. Water to steam. Different naming convention. Water to steam. And transition from steam to water. Cool. Transitions. This is water to steam. And steam to water.
Different naming convention.
Got flirting.
So
Uh,
is there any reason, speaking of air, that you're using the C style naming convention?
Because I was
Like,
programming a lot in C++ at work, but now I just started a whole MVVM
uh,
switch over of our main tool to C sharp.
mhm.
And so now I'm stuck in that one, and that's why I'm writing that down a lot now. And then yeah. I
Cool.
should switch this all to C sharp. But,
It's all right. It's also,
yeah,
I don't know. I was just curious. It's not like a judgment or anything.
yeah, no, I
Yeah.
work in both is the answer.
Yeah. It is kind of hard. It's like switching dialects almost, right?
Yeah.
So you know how to speak the language. It's just this you in this way you say it this way, or in this place you
Hmm.
say it this way. Yeah.
Hey,
Hmm?
do I never do that? Oh no, I do. Here you go. Oh,
Oh, yeah.
avoid typing when possible.
Y- Yep.
Oh no, I declared it too early.
Uh, you can do that before you declare it.
Uh,
Yeah, it'll let you reference in any order you want to.
Oh, C sharp. You
Yeah,
amuse me greatly.
I know it's pretty special, isn't it? That's transition, not transitions.
Uh, killing me. So we have a state material that has a size of that. Now we need to do stuff with it. So state material transition dot water steam. Hint, of course,
Hmm.
naturally. And
I
the
really
block
wish C sharp.
properties.
That's one of the few things that I think could just be way better about C sharp without, I don't know, without it being confusing.
Mhm.
Like, it should just allow you to use enums as indices into arrays because that's like such a common thing. There's
Yeah,
there's kind of
it's
no
super
reason.
common.
Yeah, there's no reason for that type conversion to have to be explicit because they're already stored as ints anyway. Like,
And even if you here say extends int,
yeah, it still doesn't
like
let you.
I'm pretty sure that also doesn't work just for this.
No, it doesn't.
Users at home. Nope,
Yep.
proven.
Yeah,
So
I use so when I'm writing code, I use basically exactly that pattern to type my integers so that like
mhm.
if I'm using even for things where I'm actually just using the enum as an integer because you don't have to use it for its defined values, right? Because it's just you can
Yeah,
derive from ints and then it's just an int. But
yeah.
so if I'm like storing indices into different arrays, I'll type them that way I don't mix indices by accident.
Ooh.
Yeah, it's very helpful. It saves a lot of bugs.
Okay, so this has to match that one.
You can make the transition temperature for the one that goes in the opposite direction negative.
Negative 0.5? That's not
Yeah,
a temperature.
right. But in the shader, you could detect the negative and say, hey, if it's so the negative temperatures are ones that go down, the positive temperatures are ones that transitions that go up.
But does it care? Yes, it does, because if it's lower than that temperature
Right.
or higher than that temperature. All right. So then the heat text is heat text, and input text is the steam, and steam goes to water. So we go looking for that, and it's somewhere down here. These are now materials. Why is it? Oh, in.
The thing that we were just complaining about.
Oh, C sharp.
Yep.
So this is outputting to water from water by transmitting steam to water because steam is the input.
Yep.
Cool. So now in the state shader, if the transition temperature, which is declared, very good, if the transition temperature is greater than 0, this pixel is, wait, yeah, and the heat pixel value, no, temperature
Hmm.
is greater than the transition temperature. Wait, the temperature can never be negative. Yeah, anyway.
It's a float value passed in, Nick. So
Yeah,
yeah.
so if that is greater than the transition temperature, then this pixel gets changed. Just straight up take the input pixel, make it this pixel. True? Yes.
I mean, water that's hot on top of steam that already exists will just trump the steam.
Mm, this pixel plus. And so in the other direction, if it's
Hmm.
less than 0 and heat pixel is less than the negative of transition temperature,
Yep.
then this pixel, which I am now water, is water plus steam. But they're both adding. Something has to subtract sometime.
So it is well in the second case, it's if the transition temperature is less than 0, then you're leaving this. Like you're removing from this. So in this case, it should be just zero, right? This pixel zero because
Mm,
because when it transitions, all of the current amount is getting transferred to the new thing. So for the first line to be true, the second for the first transition to be true, it's taking all of the input pixel and moving it into the new material. Then for this one, it should say when you're leaving it, all of the material is disappearing.
so if this is Steam, yeah,
Hmm.
so that, because that,
Because that's where it's going.
well, 0.5 times input pixel,
Hmm?
let's just say, it takes half of the thing,
Okay.
just for fun.
Oh, okay.
So
Sure.
then this takes is then halved. True?
Yes. Yeah, this. Okay, so now we have some problems. Um,
Why?
so because this works, except that so uh, let's go back and remind people who are watching about high school physics. Um, when you transition from one state to another, there's a
Mhm.
heat of what is it called? Like heat of evaporation and heat of condensation. That
Yes. There's
there's
a tinge of
actually
heat.
heat. Yeah, there's actually heat consumed or whatever when you change state, and that's what
Mhm.
causes the different, or I guess what allows the different states of matter to have different heat capacities. So if we just do this and completely
Mhm.
transition one state to another, and because we're tracking heat and not temperature, the temperature is going to go up or down depending on the state, which
Mhm.
is
Which is very true.
going to be weird, but maybe that
But
just
this
works in
should.
this universe. You know what? We're making our own physics, so
Nice.
we'll see what
So
happens.
yeah, the current objective is we have steam and it's going to be cold when I place it.
Yep.
There is no heat. Why is it not water?
Hmm.
I have water and I heat it up. Ah, steam!
Look at it go. That's awesome.
It's steam!
Look at it steaming.
Woo!
I don't know why it's not going the other direction.
Because it's hot, apparently.
Why is it hot?
But this should not be hot.
It's
That's
not.
not hot.
It's definitely
All
not
right.
hot, and it's not
Well,
going the other direction.
so what do here?
So,
So if let's go back to the main script. The main script
yeah.
takes the steam with the water to steam,
Hmm.
and the water with the steam to water. So when we have steam to water at the transition temperature of negative zero point 0.5,
Yeah, it should be triggering
uh,
the second one.
mhm,
The input text is, oh, this is steam to water. The input text is steam. Oh, because it's, hold on. It's the, okay, so we're modifying the output, which means, why is my brain breaking on this?
I
Go back
don't
to the
know.
shader, the state shader.
Hmm.
Okay, so the thing that, in the case of going steam to water, we actually, okay, well, because, all right, so this is weird. In both cases, we're creating elements.
Yes,
So in both cases, we're adding. So where do things ever get removed?
that's my question.
Okay, so this is weird. So this is going correctly in one direction, maybe.
Hmm.
So okay, let's look at this. So
So
we have in the case, let's
uh,
just consider the case where water goes to steam and water needs to disappear, not just create steam.
yes.
So that transition, which is going to be a positive temperature transition for both
Hmm.
steam and water,
Hmm.
needs to kill steam, or sorry, create steam and kill water, right?
Okay. Yeah.
So,
So the steam to water shader will be creating water.
mhm. Is that the
but
answer? Is that
but it's
each is that it's the steam to water shader? So okay, because the steam to water shader, or
is
sorry,
responsible for both
is responsible for both
killing water
directions,
and creating water.
right? It has to be responsible for both directions.
Yeah.
Okay,
So
so
we had another if here that says if the temperature transition is greater than 0 and it's less than the transition temperature, then it's minus. And duplicate this. But this seems kind of silly.
okay, so if the transition temperature is greater than 0, that means we're going up, and the heat is currently greater, then make more stuff here.
Yes. But at the same time,
So then at the same time, it would take so that would also be true of this condition down here, right? On the paired shader, because the paired shader is going to get temperature transition less than 0, and the heat pixel is also going to be greater than transition temperature, which means that this one's going to be down. Okay, so now this works, right? Because this one is, yeah, because it's going to be removing. So it's either, well, let me get my fancy whiteboard drawer out again. So it's either this one and this one at the same time, or it's this one and this one at the same time, right? Because this is the up transition, and then this is the down transition.
yes. Yeah,
So
and so
the
you're saying this one and this one at the same time in different shaders.
in different shaders, right?
Yeah.
Yeah. Okay, so that should then work, question mark?
Try it out.
All right.
See what happens. We have water. We have steam. Steam? Steam? Hello, steam? Steam, please. No steam.
St- st- Steam isn't hot enough to exist. It just creates a tiny amount
Water
and
plus heat does no longer exist.
then so
So
Steam,
this is what I'm thinking. We have
what's up?
we have we have two transition temperatures.
Okay.
Transition up and transition down.
All right.
Transition hot and transition cold. Because if you have something that can transition to something else, it necessarily can transition in the other direction. True?
Mm-hmm. Yes.
So declare all of this business twice. Transition hot, transition cold. And that means, what does that mean? Main script. Main script, we have some of these.
You do these all positive.
Yes,
Okay.
I think for now. I'm not sure. I'm going somewhere, but I'm not sure
All
where.
right. I'm on the ride. Let's do it.
So we have a hot and a cold temperature.
Yeah.
When water transitions to steam,
Mm-hmm.
it transitions at a hot temperature of 0.5.
Yep.
When steam transitions back to water, it does so at a colder temperature of, let's say, 0.4.
Okay.
When steam transitions to water, it does it in the same way.
Sweet.
Or active, should we call them active and reactive? I don't know. Because then how does it know which one it needs to do?
Right, because it's depending on which one it's writing.
Yes. But you know what?
Hmm.
Can we? No, because Steam. Wait, flow shader. GBRA is free.
What is this? What are you doing? What are you doing?
So here we output
Yeah.
to A, and with the other one, we just take minus A.
Oh, okay. Wait,
Uh,
does that work?
yes. So in the transition shader,
Yeah.
we say this is going to transition. So if the temperature is hotter than this,
Mm-hmm.
add add value based upon input parameter.
Mm-hmm.
And if it's colder than this, subtract from this based upon input value because it's going to be going back to the input value. And in the next shader, it says change the input value to negative that. So if it had flowed into here, it subtracts from here, and if it flowed out of here, it will add to here.
All right, let's try it.
Which means we need a, how do you say, a pair shader? I don't
That
know.
what do you mean that all it does is just the opposite of what the other one did?
Yeah, pretty much it's just the
Yeah.
opposite of the other one, but that means we need another shader. Oh,
But then don't you have to write both materials or be able to write each one in order to do the opposite?
mm, you do one of them in one, and you take that as the input to the second one, which writes the first one.
Okay,
So
got it.
yeah, so we'll
Let's
have we'll have this shader that modifies water, which has an input to this one, which then modifies steam, which it wanted to modify here.
but couldn't.
Yeah, so water dot A equals the change in steam,
Mm-hmm.
and then you just take that and modify steam.
Got it. Yep, that makes sense.
Yeah, this is kind of silly beans
Yeah, because yeah,
because
you're just
we want to just modify two textures, but we can't.
right, but you can't. Yeah. Okay.
So state shader 2 gets renamed to pair state material. And the pair state shader.
Fortunately, this one's pretty simple.
Indeed, quite simple. So in the pair state shader, pair state, we have some text and an input text, and we don't care about any of that. Doop-a-doop, doop-a-doop. And this pixel dot r
You still need to sample this
equal
pixel.
to conflarment.
Don't get hasty with your deleting.
I love deleting. This pixel dot r plus equals to uh, input conflarment.
Yep.
No, yeah,
This pixel.r
input.
or today.
I need to sample
Wait.
the input
Oh yeah,
texture.
you do.
All
Put it back.
right, there we got two.
Yep.
This pixel
Wait.
dot
Put
r.
above the, you have to return the whole pixel. So if you want to just modify the R element, you got to do it on a separate line, not in the return statement.
Rebel. This pixel dot r. Fifth time. This pixel dot r plus input pixel dot a. Done.
Nailed it. First try.
So first try. Now we have a pair of the state materials, which actually, so these will always be in the hot direction
Mm-hmm.
for consistency. State change and pair state change for Going cold.
Getting chilly.
We have a pair state material. The pair state material is the same size as the transitions because it's always going to be that way. We make sure to update our shader to use the right pair state, and we need to import it into the quad under pair state material, state what?
Hello?
Hello? What did I do?
Oh, they get updated.
Hello. Private.
You have a compiler in here, which is why it's not updating this.
Boo.
Yeah.
Well, that's fine. We'll do that later. So we have pair state material.
Yep.
And we go look for state material. And that's here, which means we don't need this one. But we do need pair state materials of pretty much some of that.
I'm not going to talk about how you just deleted the code that was exactly like this.
Did I?
Yeah.
I guess so, huh? Yeah, I'm pretty concentrated. Like, this is hardcore stuff.
Yep.
So we have to pixel. We don't need this. We don't need heat.
Right.
But the flow texture's
It's the
input
output.
is the output of the hot,
Right.
which is this one, which is steam, because this is inputting water and outputting steam. This one's inputting steam and outputting water. So the pair state material somewhere down here. So this looks like it could be a pair state material for water to steam that outputs to water. And then we just have to modify the state material. Pair state material is probably a bad name. I think I messed up there.
That's all right.
In the state
got
shader, ooh, you still need hot and cold?
Yeah. Well, you're going both. Wait.
Yes, we do need hot and cold.
No, you don't need hot and cold because
Yes,
you have one and you don't have a reverse direction.
Ooh, but we do, don't we? We have to delete ourselves if it gets too cold. Yeah.
Okay.
I think this is where I was headed with it. So
okay. All right.
Some
Cool.
hot temperature.
Yeah.
So the temperature. So if the heat pixel A, which is temperature, is greater than transition hot temperature, we're going to add to this pixel sum of the input pixel.
Right.
And
the amount of input pixel that we added is going to be the amount that you remove.
This pixel dot A, which is the amount that needs to be removed from the input pixel. So actually, you know what? We could do float amount to shift is this much. And then amount to shift is that. And this is that. This needs to be removed from the other one.
Right, but we also have to pass it through as a scaled value. So it's in the 0 to 1 range.
True. So we do the 0.5
Yep.
plus 0.5 times that, which means in our pair state shader, we need to do times, oh God.
Is it times 2 plus 1?
Oh God, what am I doing?
Right.
How does this work? Times.
Or it's times 2 minus 1.
It's that. It's 2 times that minus a half in parentheses.
Yeah.
That works. Starting to get that time again.
I know. We're almost there.
Keep trucking. Keep trucking.
We're going to truck to the point where this at least runs.
So this pixel plus 2, so that's the...
Yeah, that's scaled correctly.
Yeah, cool. That's scaled. Right. This is scaled. This adds to that.
Yep.
Will this ever be negative? No, it will never be negative.
Right.
Very good. So that's if it's hot. What if it's cold? If it's less than cold temperature, then the amount of shift is negative that. Negative this pixel.
Ah, right, because you're subtracting from here.
Yeah.
Yep,
Negative half of this, and this plus the amount of shift, and this
yep.
pixels A's is negative the amount of shift,
It's negative the negative.
which is positive,
Yep.
which means the other ones will add it. See if it
Just
works. Filing scripts.
you need to assign your pair state material into the quad.
Do I?
Yes, because you couldn't do that before because it was
Ah, because I couldn't.
yeah, there's the there.
Oh, it's in.
Okay.
Doing it.
So far so good.
Yeah, didn't crash immediately. I have steam? No, I don't have steam. I
Okay.
have water? I have water.
You didn't have
We
steam?
heat the water. We heat the water. We make steam. Steam immediately.
And Steam just
Blub,
doesn't
blub,
like
blub, blub, blub,
existing.
blub, blub. Steam
Yeah.
really doesn't like existing.
And if you make steam above it, then it just nothing happens.
Well, I can't make steam. So I can make steam in here, apparently, momentarily.
Huh. And you can make steam and it comes off, but then it looks like it's not adding the water that steam should be condensing into. Is that correct?
Yeah. So let's see here. I'll add a bunch of heat in here.
Yeah.
So it's really hot steam. And then we add steam in there. And it looks like as soon as it hits the edge, the steam just bubbles off,
Yeah.
which it should not be doing.
Yeah, because it should be getting converted to water.
No, it should be hot steam, which does not
Wait,
transition to water.
or that. Well, but
Uh,
the at the edges of the steam, isn't it cold there?
ooh, that would be an off by one, wouldn't it?
Yeah. If it's getting
Hmm.
bumped over the edge.
Hmm.
Well, try just turning off transition cold. Maybe that. Because I mean, it's very possible we screwed something else up. No, all right. And
It's hot.
it's taking the heat with it.
Yeah.
Okay.
All right, let's say it was.
So if the heat pixel is less than the transition cold temperature,
Mhm.
then
Then we want to subtract from this pixel, which is water.
mhm.
So oh wait, no. No, we're outputting steam here.
Are we?
Or we are steam.
Oh, we are steam.
This
Okay.
pixel is steam.
Okay. So
So we want to take half of steam
mhm.
and subtract it from ourselves.
Yep.
So we lose half of steam.
Yes. And then
In
this.
there,
Are you writing to master on these?
writing to master.
Yeah. On both of these things in the main script.
No, I'm a silly bean. Gotta blend it if you want it to work.
Okay. Those are just what
Wow,
we needed to do, right?
get wrecked.
Okay. So now we haven't solved the mystery of the disappearing like temperature because the temperature. Hello?
Uh,
Hello?
uh,
Uh
water goes to water, steam goes to steam.
okay, hold on. Are the flow textures outputting into the slaves? Like are the state materials and pair state materials writing into
These go
index
from
one?
master to slave.
Oh yeah, they are.
Oh, and then
Okay.
you gotta blend it first.
Right. Yeah, you gotta put the steam into yeah.
This is do the paired state change for steam to water. Wow, this can get complicated if I want to add state changes, huh?
Hmm.
Uh-oh, Windows is blinking at me.
It's preparing to black out your screen again.
Maybe. Oh yeah, that looks about right. Steam? Hey, it's water. Ah, great victory. So we add steam,
Steam is just
and heat.
instantly going to turn back to water, right?
What is this? What?
Because it's creating steam, and
Yeah.
the steam is just immediately condensing. I mean, it looks kind of
y-
cool, but that's not what you want.
Yeah.
So for some reason, it's doing the transition back like immediately.
Yeah. Hmm. Well, you know what? We can just try setting a different temperature there.
Yeah,
What if it's 0.1?
then everything works just fine. All right, all right.
Uh, it depends on how much it can wick from the water. So if the water is, oh, but the water can't be really hot because as soon as the water is really hot, it
Then it
turns
turns
into
to
steam.
steam. Uh-oh, we have a problem.
Uh,
Can you make lava really hot and then drop the lava in there, or drop the steam in lava?
I could put the steam in lava. Yes, so we can have lava. We can make the lava really hot. So this is really hot lava,
Mm-hmm. Hot lava.
and then we could put the steam in there, where it's steam in the middle, and then it turns into water on top, and a steam barrier in the middle. I mean, that's kind of cool.
That is cool, but there shouldn't be this little like thing of lava or thing of water just down here, right? Like I feel like that's not what should happen.
Probably not.
You know what? But we're
This
pretty
is
we're pretty close though.
interesting.
Yeah, getting the old red, white, and blue in there.
The objective all along.
It's complete. You're done. Ship it.
Yeah, ship it. So this is interesting though, because like it's just on the barrier of point 0.1,
Huh,
so it
yeah, it
doesn't
looks
it doesn't have enough it doesn't have enough heat to heat up the entire volume,
hmm
but as soon as it goes outside, it cools to zero-ish. And so I can add here, I'm just adding heat, and
hmm
apparently that creates water, which is
Well, because the
cool and
steam
all.
kind of expands, right, into the area. And it looks like it can't flow because as soon as it does, then it starts going into steam again. And it's probably some sort of, you know, transition that just goes back and forth between steam and water over and over again.
Yep, but I'm pretty sure this isn't supposed to be able to happen.
What, you mean creating matter by adding heat?
Like I'm
Looks cool
pretty
though.
sure. Oh, it looks fantastic. Steam is there. Yeah, steam's still in there. Water's kicking. But
I think this looks like a project for next time.
indeed it does. I think it has to do with these temperatures. I'm not
Yep,
sure.
I think
We'll
you're
figure it
right.
out.
That sounds good. Well, I feel like we made a lot of progress and then deleted a bunch of stuff and then made a little bit of progress. So today is one of those two steps forward, one step back situations, but
Yes,
I
very
still had
much
fun.
so.
I still had
Yeah,
fun.
it's a great time.
All right. Well, I look forward to seeing what we can get set up next time.
Me
I
too.
think we're going to sign off for tonight. And as always, I'll post the VODs on the YouTube channel if you guys want to catch up on that. And feel free and leave us comments or message us here at Pretty Simple Fun. Let us know what else you want to see, how you like the show, any of that sort of stuff. Any parting words, my brother?
Uh, C#. It's the best.
Perfect. And with that, we're out. Good night, everybody.